Y. Amanat sir to deliver his speech. Please, sir.
Okay, okay. So now it is clear, right? Okay, madam. Thank you. Good afternoon, all.
Yes, sir. Hello?
Yes, madam. Yeah, shall we
It is
start now
audible.
then?
It is, yes, sir. We'll start.
I will start now then.
Sir, again, Samya, you will introduce to the sir.
Yeah, I will introduce and
No, sir.
start this
CH,
session. Okay, madam.
uh, okay, sir. CH, all 1 minute. CH,
Sorry.
she has already introduced you, but maybe due to network connection, maybe teach. No problem.
Okay, okay, okay. Yeah, then I will start this session.
Okay,
Am
sir.
I audible, ma'am?
Yeah, you are audible. Okay,
A
you
very
in.
good afternoon to the team delegates, respected faculty members, and participants. It is my privilege to introduce our distinguished guest, Dr. Y. Amanat sir, who is currently serving as a professor at Srinivasa Ramanujan Institute of Technology, Andhra Pradesh. Dr. Amanat holds an MS degree from the IIT Madras and PhD degree from University of Dundee. He is the founder and managing director of Ananya Engineers and brings with him over 25 years of professional experience. His expertise spans construction materials, sustainable constructions, lightweight materials, RCC structures, steel structures, STAD analysis, and many more. With a great respect, I now invite Honorable Dr. Y. Amana sir to deliver his speech. Please, sir.
Thank you, madam. Thank you for your introduction about myself. Good afternoon, all. Now, I think my slides are visible, right?
Yes, sir. It is visible.
Okay, madam. Thank you. So now we are going to discuss about properties of foam concrete and its applications in our AICT sponsored Atal training program. As she, madam, right now introduced about myself, I am founder and managing director of Ananya Engineers. Through that, we are serving construction activities, starting from analysis of the structures till construction activities we are rendering. Apart from it, I am doing teaching and research as well. So now my main PhD project was on foam concrete. That's the reason why now I am going to give presentation on foam concrete and its applications and properties. So this presentation outline is as follows. So we are going to understand about foam concrete and its definition, methods of production of foamed concrete, constituent materials used in foamed concrete, flash in foamed concrete, because this our training program main title, I think it is on sustainability. Flash is one of the materials we if use in concrete. So that that material we can make that material. Fly ash has a lot of scope in foam concrete usage. So that's the reason why we are going to discuss about fly ash usage in foam concrete and fresh properties, compressive strength, and other properties of the foam parts. This is about outline of this presentation. Now coming to the foamed concrete. Foamed concrete, if you define, it is a cementitious material where air is entrained by the mechanical incorporation of preformed foam or admixture into a mortar. So that is called foamed concrete. So it is a lightweight material. In cementitious material, we incorporate foam into that cementitious mortar by some other external activity. So there are three methods by which we can introduce foam into a cement mortar. First one is pre-formed foaming, mixed foaming, and third one is combined foaming. So coming to the first method, that is incorporation of foam into the foam concrete to produce the foam. So before producing foam concrete, first we need to produce mortar. As you can see here, you need to produce mortar, cement and water we need to mix. That is cement mortar. It need to be very durable. I mean, flowable material. So it need to have some consistency. So at that level, we need to incorporate foam into that particular mortar to produce formed concrete. We need to introduce air through foam into that mortar. So those three methods are fine. First method, pre-formed foaming. So once we produce the mortar, afterwards we need to produce foam. So this foam is incorporated into this mortar to get the foam concrete. This is the fresh state property, fresh state of this formed concrete. And this is the hardened state, how it looks like. This is the first method. So to the mortar, we need to produce the foam separately, and we need to add these two to get the formed concrete. That is mortar and foam. So to get the concrete, that is formed concrete. So here in second method, mixed foaming method. This to produce foam concrete in second method, this is the mixed foaming method. In this mixed foaming agent is mixed directly with the plastic grout. So here mortar is mixed with the foaming agent, directly liquid. In earlier method, we are producing foam and foam is adding into the mortar. In second method, we are directly incorporating foaming agent into the mortar, and that is mixed to generate the air bubbles in this particular concrete to make the concrete lightweight, and thereby it is the foam concrete is produced. In third method, combined both the in this stage both foaming agent as well as air entraining agent are used to produce the foam concrete, are used into the mortar to produce the foam concrete, to make the concrete lightweight. So these three methods are used to produce the formed concrete. Formed concrete has its unique properties. That's the reason why formed concrete has its own applications that we are going to discuss in this presentation later. So we will discuss first the unique properties of this formed concrete. First one is self-flowing. It is self-flowing. It is like a liquid. We can just drop through as like water. So it flows like water. As you can see here, the workability of this foam concrete is very high. Just we can pour the as a water. You can see here. And the self-compacting, it should never be compacted. Why? Because it already contains air bubbles into that. If you allow external energy to compact, that air bubbles will destroy and there won't be any foam concrete later. That's the reason why the external compaction is not needed for formed concrete. It is self-compacting. And the third advantage or third unique property of this particular concrete is we can produce range of the densities. This is the major advantage of our major property. I mean, the unique property of this particular foam concrete. You can produce a range of densities starting from as low as even you can produce 200 kg per meter cube and as high as 1800 kg per meter cube, depending upon the applications, depending upon where we are going to use this particular formed concrete. We can produce the range of densities. And the other property of the foam concrete is light in weight. So, as we are, uh, when you compare with the normal concrete, actually, I think we all know normal concrete density varies from 2,400 kg to 2,500 kg per meter cube. But as we are discussing right now, the foam concrete can be produced depending upon your requirement, as low as 250 kg per meter cube to as high as 1800 kg per meter cube. You can see here. And the thermal insulation of this particular foam concrete is almost equal to thermal insulative property of wood. So it ranges from zero point 0.1 to zero point 0.7 watts per million Kelvin. And it is low cost per unit volume to produce. Why? Because to make the concrete, we are incorporating air into it. So that's the reason we are making we are increasing the volume for the same solid content. So that's the reason why for a particular unit volume, when compared to normal concrete, it is low cost. So now we are going to discuss what are the constraint materials that can be used or that are used in foam concrete. So we normally use the constant materials same that whatever you use in normal concrete, uh, except we are not going to use any coarse aggregate in foam concrete. Coarse aggregate never be used in foam concrete production. So you can see here the cement as usual, cement as a binder we need to use in foam concrete. Fine aggregate, depending upon again the density, we need to use fine aggregate in foam concrete. Flash, again, depending upon density and availability and requirement, we can use flash in foam concrete production or other mineral admixtures equivalent to flash like GGBS, Ricel's cash, all other mineral admixtures can be used to produce foam concrete. And as usual, water. And the extra material that we use apart from production of normal concrete here is foam. This is a main constant which makes this foam concrete is foam, as we have discussed earlier. So the three methods, using three methods, that is preformed foaming, mixed foaming are both the methods. We can produce foam concrete, or we can produce air bubbles into mortar to make the volume high and the density low. So that is how the foam concrete is produced. And these are the constant materials that we use to produce foam concrete. These are the basic constant materials to produce foam concrete. That is cement, fine aggregate, fly ash. Again here, fly ash and fine aggregate, both are depending upon requirement. Without these two also, we can produce foam concrete. Just only cement, water and foam, we can produce foam concrete. Without these two, that depends again on density, requirements of strength or applications. That depends whether we need to use fine aggregate, fly ash, or both, or any other material. So that depends. So these are the basic constant materials that we use in production of foam concrete. Now, as we are discussing, this training program title is Sustainable Construction Material, something like that. So, as we are discussing, fly ash is one of the waste materials that we use to produce some concrete. So, foam concrete is also not exceptional. We can use foam in majority of the cases to produce the foam concrete. So, fly ash can be incorporated in foam concrete. Majority of the foam concrete mixes fly ash is used in majority of the cases. Sometimes in place of sand, only fly ash can be used, depending upon uh, density requirement and applications, all these things. And fly ash is replaced either by cement or by fine aggregate, as in normal concrete. Fly ash can be replaced either by cement or by finer grade or the same density. For the same density, we can replace flash either by cement or the replacement levels are as high as 80% by mass of cement. So as high as 80% by mass of cement, flash can be replaced in foam concrete production. Whereas it is up to 100%, as I was saying, sometimes we need not use any sand content into concrete or foam concrete to produce foam concrete. So that's the reason why 100% flash can be produced. Only cement, flash, and foam can be used to produce foam concrete like that. So if you use flash in foam concrete, it the consistency of the foam concrete increases as in normal concrete because as we all know the flash has ball bearing effect. The microstructure of flash is of micron level. If you observe flash, the particles are in ball shaped, so that helps increase in uh, consistency. Same helps as it helps in normal concrete, that property of flash. Same helps in foam concrete. So when if you use flash in foam concrete, the consistency increases. Like you can reduce the water content. And long term strength, as we all know, the pozzolanic activity of flash improves long term strength of normal concrete. Same is applicable for foam concrete as well. And on the whole, the flash in concrete, in foam concrete as well, increases performance of the foam concrete. Now, up to now, we have discussed what is foam concrete, what are the properties, special properties or unique properties of foam concrete, and how we can produce foam concrete, flash in foam concrete. I will see what are the properties of foam concrete. Fresh properties of foam concrete. Foam concrete is having self-flowing ability up to 1800 kg per meter cube, as we have discussed earlier. The fresh property, and this is a unique property of foam concrete, has self-flowing ability. Just we can pour the concrete like water up to 1800 kg per meter cube. However, depending upon density, this flowability changes. At very low densities, flowability may not that good. Equally, at very high densities, the flowability may affect. So, depending upon the density, the flowability of the concrete affects. But the on the whole, the foam concrete is flowable material. As we have discussed earlier, for same density, if you use flash for same density, same water content, if you replace cement with flash, the workability of the foam concrete increases because of ball bearing effect of foam concrete. As you can see here, the microstructure of the flash, you can see the round ball effect, ball bearing effect will help the foam concrete in increasing its flowability. Coming to the very major or very important property of the concrete, property of concrete as well as for foam concrete, it is important. The compressive strength of foam concrete. You can see here there are this is one of the examples that I have taken from one of the research papers. Uh, in this particular graph, this is for only Portland cement that we have used as cement. The density of this particular concrete is 1400 kg per meter cube. Water cementage is 0.35. And so there are the curing condition. Majority of the cases, while working in a laboratory, foam concrete generally not cured with external water as we cure like normal concrete. we wrap that concrete in cling film, and that is how we cure foam concrete. And here, the curing condition is wrapped in cling film and at temperature of 22 degrees per centimeter, and relative humidity is 55%. Under certain environmental conditions, this particular concrete being produced and cured. And foaming agent is synthetic. Usually, there are two types of foaming agents to use to produce foam concrete. One is synthetic, and the other one is protein, animal protein as well as vegetable protein are available. Using those two foaming agents, we call that as surfactant. So we can use synthetic or protein. In this particular case, synthetic surfactant being used. So if you see this particular graph here, the line here under one is of sand concrete. We have used sand to produce concrete, and the other one is flash concrete. So instead of sand, we have replaced with flash. So if you see here, this particular first this one, as age increases, the strength is increasing and sand concrete as well as same thing is happening in fly ash content, but the increase in strength, rate of increase in strength is very high in fly ash concrete as age increases. But here, once it reaches to a certain level, almost it is reaching to constant. Strength gain is not that much. Same thing happens in normal concrete, and here also the same way. So, because of this advantage, addition of flash in foam concrete, there is a possibility of producing structural grade foam concrete. But uh, getting strength at lower levels in foam concrete is difficult. So, we need to we need to produce 1400 and above density concretes to have structural concrete. So this is how the strength of the foam concrete is with, with time. So coming to the other important property of concrete, which is permeability. Concrete permeability is mainly influenced by the porosity of the concrete and interconnectivity of the pores. So the here we need to observe permeability depends porosity as well as interconnectivity of the pores. If the pores are available, that pores need to be interconnected, then only the permeability happens. If pores presence, if there is no interconnectivity, I think permeability may not be that much. So if higher is the porosity, higher is the permeability. Because if higher is the porosity, there is probability interconnectivity of the pore system is increases. Thereby, permeability increases. So this is what happens in normal concrete. Similar thing happens in formed concrete also. In formed concrete also, formed concrete increases in density, permeability decreases. So why? Because as the density increases, if you see here is one of the papers, research papers have taken this. If you see here, water vapor permeability, as density is increasing, the permeability is drastically decreasing. Why? Because as density increases, porosity in the concrete reduces. Thereby, the permeability decreases. This is how it happens in foam concrete. In foam concrete, for the density increases in flash, the place of cement content, interconnectivity pores increases and thereby permeability increases. At the same density, if the sand is replaced with flash, interconnectivity of the pores reduces and thereby permeability reduces. Here, the comparison in this third statement, the comparison is between replacement of flash and sand. So if we replace sand with flash, the pore system reduces. Why? Because of for same sorry pozzolanic activity, the solid material in that particular concrete increases, so thereby pore system reduces, and the permeability increases. If you see here in this particular graph here, as the porosity increasing, the permeability is also increasing. If you see here, the porosity is increasing and the permeability is also increasing. So porosity influences porosity as well as the interconnectivity of that particular thing influences the permeability. Same thing happens in in foam concrete. So absorption is also one of the important properties of concrete. In concrete, water absorption is mainly governed by the capillary pores. So if the capillary pores presence, then through that capillary system, pore system, the absorption action, because of suction, the absorption happens in that particular concrete. As paste phase has the more capillary pores and it mainly influences water absorption. So paste phase influences the absorption of the concrete and not artificial pores. Please remember here, paste phase interconnected pore capillary pore system influences absorption, not artificial pores. So now, if you come absorption property of foam concrete, contrary to normal concrete, in foam concrete, the absorption increases with increase in strength. Usually, normal concrete, what happens as the strength increases, the absorption decreases. But in foam concrete, at lower levels, there are artificial pore system presence. So that's the reason why capillary interconnectivity disconnects that artificial pore system and the absorption increases at lower levels. So please observe this particular statement. Contrary to normal concrete, in formed concrete, the absorption increases with increase in strength. As strength increases, absorption increases in formed concrete. But that is not in the case of normal concrete. In normal concrete, as strength increases, absorption decreases. The absorption increases with increasing density. Why? Because if you want to increase the density, the paste content need to be increased. Thereby, absorption increases because the paste phase in foam concrete increases as density increases. And for same density, when compared to sand mixes, water absorption is more for fly ash mixes. Again, here sand is high dense material and fly ash is low dense material. So if you replace sand with fly ash in foam concrete, the paste phase increases and thereby capillary pore system increases and the absorption increases. And with the increase in fly ash replacement with sand, water absorption increases due to increased paste content. That's what we have discussed in earlier statements. So this is how the absorption property influences in foam concrete. Absorption. Similar to water absorption, absorption increases with increase in density. As density increases, absorption also increases. This is because artificial bubbles in foam concrete act as force aggregate and obstruct. As density decreases, the artificial bubbles increases. As density decreases, artificial bubbles in foam concrete increases and absorption decreases when compared to solid here. Flash in foam concrete increases absorption when compared to sand mixes at same density due to increased paste content. As we have discussed earlier, same happens with the absorption property as well. At the same density, absorption increases with increase in foam flash content. Now coming, these are the few unique properties of foam concrete and a few properties of foam concrete that we have discussed as of now. Now coming to uh, applications of foam concrete. Foam concrete has a lot of applications. We can find a lot of applications uh, in normal construction applications. Foam concrete can be used many of the places. In which first one is void filling. This concrete is very useful at lower densities because at lower densities, cost to volume ratio is very uh, low. So therefore, we can use the low density materials to fill the redundant places like old sewage pipes. Say there is a sewage pipe, old sewage pipe, which is not no more useful. If you see here, this is one of the sewage pipe. So that is filled with foam concrete. Sometimes it may be cheaper than soil. So if you transport from somewhere to here, that may be costlier when compared to, but we need to compare the cost comparison need to be done. So we can use that foam concrete to fill the old and redundant pipe system, sewage pipes, or any other pipe system which is not in use. And open wells. Many places we may find the wells which are dangerous for normal living life. So such wells, instead of filling with normal sand, so normal soil, uh, we can use foam concrete to fill that particular. Uh, we can fill that those wells uh, with foam concrete, low density foam concrete. Likewise, cellars, basements of old buildings, all places where the structure is no more in use, we can use instead of sand or instead of soil, we can use foam concrete to fill that particular redundant structure. Storage tanks, tunnels, and subways. These are the places where we can use foam concrete as a filling material. Next, as a backfill material for behind queues. Now, if you see here this particular thing, this is the queue. Behind this, you can use uh, as a backfilling material instead of soil. We can use the proper density foam concrete to fill these queues, as well as bridge abutment to reduce the lateral loading. If you see here, this is the one of the abutment walls that you are seeing. So if you fill this behind this, if you fill this with the foam concrete, why? Because after getting solidified, the lateral load on this particular wall will be reduced. But if you use same way, if you use soil or sand to replace or to fill this particular area, what happens over a period of time, this soil incorporate pressure onto this particular abutment. So thereby, the design cost of this abutment increases. This is also one of the advantages of foam concrete. The uh, lateral loading can be reduced because of its own sustainability. If you see the other applications like soil slope stabilization, we can use foam concrete as a slope stabilization. One of the economical applications for stabilization of soils. A replacement for weak soil to avoid settlement. So you can take in many of the cases, you can take out the weak soil and replace with that. Next, it can be used as insulating fill in the firewalls. Soundproofing system, it can be used a thermal acoustic material, I mean, soundproofing material. Foam concrete blocks, in many of the places you might have seen in construction, foam concrete blocks can also be used. That is because of lightweight that blocks are now it is becoming popular. These few are the projects that major foam concrete applications that were happened. These are the few projects that we have noticed. One of the projects that is Kumdown. This is one of the world's biggest foam concrete application project. This was used to stabilize mine stabilization. The volume of the concrete, formed concrete, was 5 lakh cubic meters. You can imagine the volume of the concrete that they have used. This is in UK, United Kingdom. Density of the concrete that was used 600 kg meters. And that's what I was saying. Fully redundant structure. And harbor fill, that is 19,500 cubic meters, 500 density of the material used. Road subbase construction for subbase construction, that is 73,400 meter cubes of foam concrete. These are the few projects in majority, I mean, few projects that we have listed here, in which the major foam concrete application was happened. And so if you see, there are different types of applications here. This is mine stabilization, harbor fill, road construction, tunnel stabilization. Road construction means for subbase. So subbase foam concrete can be used. So this is about this presentation. Please, if you have any doubts or clarifications, please, we can have some discussion. If you have any doubts, anybody, please, we can have discussion.
Participant can ask the question related to research work also and other also.
Yeah, anything, any research work, any doubts, you can ask, no problem. One more thing is in our PhD project, we have used many of the waste materials to produce foam concrete. Actually, not only fly concrete, we have used bottom ash, foundry sand, crumb rubber, glass, all these materials that we have used in foam concrete. Why? Because in foam concrete, strength is not the criteria. Strength is not at all criteria, depending upon application. So we can use many of the waste materials to produce foam concrete. And it is advantage. We can avoid natural sand application wherever natural, natural soil filling. We can use this foam. This is sustainable material. We can save the natural soil. And cost wise also, it is cheaper. Again, we need to compare the available cost as well as this foam concrete. Depending upon that, we can choose this material. Not only non-structural applications, few of the researchers they have used this for structural applications as well. And in few of the research cases, they have used, they have added fibers into it to improve. Because one of the problems in foam concrete is shrinkage is the problem, because we don't use the aggregate, coarse aggregate into it. So shrinkage is the problem. to avoid that, few of the researchers used fibers into it. So this is how the foam concrete. Okay, madam. If they have any doubts, even they can contact through email or WhatsApp number. Yeah, anybody. So is it right, madam? Or madam?
Sir, participant question, may I ask any question? Hello, is it
Yeah,
audible
please.
to?
Hello, ma'am.
Yes, yes, ma'am.
Yeah, my question is, what about durability aspects and what are all the chemicals which are used for foaming?
Again, yeah, that's what we are saying just now. That depends upon applications because if it is a structural application, durability is important factor. But if it is filling applications, durability is not the matter. How we apply, because we are using as a soil, the durability may not be the issue, and it is durable anyhow. Uh, that depends upon applications. And again, you are asking chemical that I could not get you. What is that you said chemical?
So for foam concrete, we will use some chemicals, right, for mixing. We will use some chemicals
Yeah,
to get the
that's what I was
foam.
saying. Yeah. That's what I was saying. That is called surfactant. There are two types of surfactants that are available. One is synthetic
Okay.
surfactant. The other one is protein surfactant. In protein surfactant, again, there are two types. One is animal protein. The other one is nowadays the vegetable protein is also available. So in these two surfactants, as per our research, actually, the protein surfactant compared to the synthetic surfactant produce can give the, I mean, performance is higher when compared to, for say, for same density, if you use protein surfactant and synthetic surfactant, protein surfactant performance is higher, means density, I mean strength. Say if you take characteristic strength as one of the parameters, strength may be higher when use protein surfactant when compared to this synthetic surfactant. Yes, madam, that is the thing.
But what about cost, sir? Because we are using all those chemicals, right? So I think it is expensive or what?
No, it
Those.
is not. That's what I was saying. It is not expensive actually. That is chemical is not expensive, and we use that chemical. In fact, that is just surfactant. It is like soap. We use into water
Okay.
and we stir it to produce foam. Stir in the sense at higher pressure we produce foam. Uh, Again, whatever you are saying, the cost is the comparison. It is relative anyhow. So to which material you are comparing, that is important. Where you say you are using this foam concrete for some of the filling applications, right? That's what I was saying earlier. Say at your place, soil is available, natural soil is available is readily. Just you can pour that water, sorry, that soil into the wherever you need it. But in some cases, that soil you may need to transfer from somewhere, right? So, and in that case, in that scenario, you may use this foam concrete as filling material. So again, that depends upon how we compare with this, with which material you are comparing. Cost is also relative, madam. Okay.
Yeah. Okay, sir. Thank you.
Sir, one more question is in chat box. Sir, what is the difference between SEC block and foam concrete? Uh, this is one question. And another one is, and is there any IS guideline for mixed design?
A guideline for mixing design, yes, madam. Yeah, actually, these two concretes is always confusing. Actually, A is autoclaved aerated concrete and foamed concrete. Both look almost same. Here, aerated autoclaved concrete production method is different. formed concrete production method is different. In aerated, autoclaved aerated concrete, for production of foam, we use aluminum powder, and at higher temperature, these autoclaved aerated concretes are produced. But in foam concrete, that is different. So we need not to have any autoclaving system. We produce foam separately, or we can directly use foaming agent into the concrete, and we can produce. So altogether, these are different, but both are lightweight. Both are lightweight. Both look like similar material. And coming to IS guidelines, as of now, I don't think there are any guidelines for production of foam concrete design. I mean, mixed design. I don't think there are any guidelines at the moment. I don't know. Yeah, that's the thing, madam.
Any SCI and ASTM?
See, when I was doing, there was no guidelines. Just I need to check right now if they are available. I don't know.
Okay, sir. Any more question from audience participant? Sir, you can explain about your industry also if you want.
Yeah, my industry.
Yeah.
Actually, I started my construction. It is not industry. In fact, it is service company. We through that company we are rendering construction activities. Actually, although I have finished my PhD, out of my interest, out of my passion, I am into this construction activity. Uh, in our construction company, we are doing approvals, structural designs. At the moment, we are confined to RCC structures in majority of the situations because our place is it's a small town. So only college that we are doing right now is up to G+5 residential structures only. So we are approvals, structural designs, and I mean supervision of the buildings. Even our company take up the building developments, all of these things, madam. But we have plans to expand it. At the moment, it is difficult. Real estate is very, business is very, I mean, dull. So it may take time. So apart from it, I'm into teaching activity as also. That is about our company, madam.
Thank you, sir.
Uh, and here, okay, I will call you, madam, regarding research activity. I will be in touch with you. So is that okay, madam? Shall we conclude this session?
Participant, any question you may ask?
Yeah,
Because,
any
sir,
question?
our next session is from 3:30 p.m.
3:30 p.m. Okay. We gave a lot of time, it seems.
Yeah, yeah, yeah.
So I am posting my WhatsApp number if anybody, any for research queries or for any other requirement, just you can contact me through that WhatsApp number for this particular research, I mean material.
Okay, sir.
have you done anything in this foam concrete, madam? Murmu, madam?
No, sir. Till now we have not started on that form
Not
contract.
yet started. Uh, do you have any ideas to do that?
Yeah, we are thinking that NTPC plant is request that you people may use the flyers.
Uh,
That's one.
okay.
So
We are
in
we are
form
having,
concrete also mainly flyers we are using, no, and some form we are using.
yeah. And that's what I am asking. Actually, if you are interested, we can associate as a in the research activity also. I think we have discussed earlier.
Yes, and sir,
Is there,
you share your PPT also. That participant will need the PPT.
excuse me, it's not responding.
FTP.
That
Oh,
PPT,
yes, sir. PPT is required for Atal
yes,
FC.
madam. Yeah, I will share that.
Yes. Sir. Soumya. Okay. Okay, sir. So now next session is 3:30 p.m. and speaker will join 10-15 minutes after next speaker. So we'll again meet at 3:30, 3:15.
Okay, madam.
Thank you.
Thank you for
Thank you
giving
very
this
much, sir.
opportunity.
Thank you very much. And if
Okay,
you have a question, participant, you may contact to sir by email also and by mobile number also.
yeah, okay.
Thank you,
Thank you,
sir.
madam.
Thanks. Thanks.
Thank you so much, sir, for giving a valuable information about foam concrete.
Thank you, madam.
Hello. We'll rejoin at 3:15 p.m. Yeah, it is audible. Sir, you can present and visible also.
Hello, hello. Am I audible? Hello. Am I audible? Okay, let's start. Let's start. Sorry for the technical issues. Okay. Our topic is development of sustainable cement compounds. Gray excellence, sustainable. Today, tomorrow, forever. It means when we produce cement, then always we have to keep on our mind that we have to produce sustainable cement for the well-being of human and uh, like कि हमको ये ध्यान में रखना होता है कि अगर हम सीमेंट प्रोड्यूस कर रहे हैं तो कि आज हमारा कैसा होगा, कल हमारा कैसा होगा और आने वाले समय का भी हमको ध्यान में रखना होता है कि कैसे हम सीमेंट प्रोडक्शन के साथ साथ अपने अपने आसपास के एटमॉस्फेयर को भी हम ध्यान में रखें, उनको किसी प्रकार का कोई हार्म नहीं होना चाहिए, एटमॉस्फेयर क्लीन होना चाहिए और किसी प्रकार का कोई हार्म जो है उस हमारे सीमेंट प्रोडक्शन की वजह से नहीं होना चाहिए। तो उसके लिए हमको हमको मेन जो चीज़ हमको ध्यान में रखना चाहिए, जो मेन जो हमारा ऑब्जेक्टिव है कि कार्बन एमिशंस को कैसे हम रिड्यूस कर सकें। और इन्वायरमेंटल गैसेस, नेचुरल गैसेस है, काफ़ी सारे नेचुरल गैसेस हम लोग अपना सीमेंट प्रोडक्शंस में यूज़ करते हैं। तो उसके वजह से जो एनर्जी कंजप्शन होता है, तो उसकी वजह से जो हार्मफुल गैसेस जो है वो एटमॉस्फेयर में रिलीज होते हैं, उनको हम कैसे रिड्यूस कर सके, ताकि जहाँ भी
Sir,
हमारे प्लांट्स हैं, जहाँ भी हमारे
sir, please,
जहाँ
excuse me, sir. Can you please
या
explain in English?
या श्योर श्योर।
Because all the participants are from all over the India, so they are not getting the hint.
ओके ओके। जस्ट अ सेकंड मैम। क्या हो गया इसको? क्या हुआ इसको? आपको प्रिंट पैसा नहीं हो रहा। कौन सा शेयर करना है? ये डेस्क पीपीटी कहाँ है? स्क्रीन शेयर है। क्या हो रहा है? कौन सा सर ये? डाउनलोड कहाँ?
Hello?
हेलो, 1 मिनट मैम, 1 मिनट।
Oh,
या तो फिर बहुत पहले भेजा है, क्योंकि मैं 2 जनवरी 3 जनवरी तक फिर चला, या मैंने इससे भेजा था क्या, शीरीष देव से भेजा।
हाँ, बंद हो गया फिर वो। कहाँ मैंने कहाँ रखा आपको? डाउनलोड्स में नहीं, डेस्कटॉप में। प्लीज। हाँ हाँ मिला सर। ओके मैम, नाउ इज इट विजिबल?
उसके साथ छेड़खानी मत करो।
हेलो मैम।
yes,
हेलो।
yes, sir. It is
Okay.
audible now.
Okay, okay, let's start. Let's start. Gray excellence, sustainable. Today, tomorrow, forever. At Sri Cement Limited, we understand that the sustainable way is the only way forward. Our constant endeavor has been offered to eco-friendly cement products to our ever-conscious customers. We are committed to delivering excellence with grey products and a green approach in our mind. Grey is more than a color, it is a powerful analogy for absorption and evolution, just like cement. This is reflected in the way we approach our businesses and operations with a sense of responsibility and long term vision. So, today, tomorrow, and forever, we have to keep on our mind when we produce cement, we have to keep in our mind that sustainability is the major issue while producing cement. So, we have to reduce the carbon emissions and other environmental effects. Cement is a cornerstone of construction industry, integral to the development of infrastructure worldwide. However, traditional cement production is one of the largest source of carbon dioxide emissions, contributing to climate change with increasing global awareness of environmental issues. The cement industry faces mounting pressures to adopt sustainable practices. This comprehensive guide explores the latest sustainable cement production techniques that are transforming the industry, ensuring that your cement plant can lead the way in green innovations. Nowadays, all the cement industries are moving towards the green innovations to control the climate changes and to reduce the carbon dioxide emissions, to control the global warming. So all the cement plants are adopting the latest technologies to for the sustainability. It is most important to adopt the latest technology and reduce the carbon emissions uh, and other harmful gases and other the like what we can say uh, other gases and other emissions, है ना, which is harmful for our atmosphere. Here you can see the graph. Indian cement industry is the second largest cement industry in the world. First is China and second is India. Not only in cement production, also in the cement consumptions. And you can see the graph here. The demand of cement consumption is growing day by day, year by year. Our demand and consumptions are growing in India. And when we see the reason wise installed capacity as on 31st March 2023, North India 111 million ton, East India 130 million ton, West India 82 million ton, South India 190 million ton, Central India 83 million ton, and the total capacity 596 million tons. Indian cement market remains underpenetrated against the global average. Lower per capita consumptions coupled with a strong focus on infrastructure development and good correlations with GDP offer tremendous growth potential for cement industry in India. Understanding the environmental impact of cement production. Let us understand what is the impact of cement production in our environment. Cement production is responsible for approximately 8% of global carbon dioxide emissions, making it one of the most significant contributors to greenhouse gas emissions. The production process involves several stages, each with its environmental challenges, like raw material extraction. Raw material extraction is one of the major issue of our uh, environmental impacts. Uh, when we extract the raw materials such as limestone and clay for producing the cements, which leads to habitat destruction and biodiversity loss, which impact our nearby areas wherever the plant installed in the nearby areas, environment get damages. Clinker production. The calcination of limestone in kilns generate the majority of carbon dioxide emission in cement productions. है ना? Like everyone know, the temperature of kiln is 1400 to 1500 degrees centigrades. When this process, when the during the cement production process, the temperature of kiln is 1400 to 1500 degrees centigrades. In this process, clinkerization, clinker form in the form of cements convert into the clinker form due to this high temperature when it burns. The energy intensive process also contributes to air pollutions and reduce depletions. Energy consumptions. Cement plants are heavy consumers of energy, primarily derived from fossil fuels, further exacerbating their carbon footprints. To address these challenges, the industry must adopt sustainable practices that reduces emissions, conserve resources, and minimize environmental impacts. Second point is alternative raw materials for cement production. One of the most effective way to reduce the environmental impact of cement production is by using alternative raw materials. These materials can either replace or complement traditional limestone and clay, reducing the need for virgin resources and lowering carbon dioxide emissions. Like fly ash. Fly ash is a byproduct of coal combustions in power plants. It is the wastage of power plants. Nowadays, it is a bigger challenge for any for government to where to dispose the fly ash. So this is the best way to use it in a cement production. Uh, Fly ash can replace a significant portion of the clinker in cement production because there is a property of cementitious property in fly ash. So it can replace the it can replace the limestone. It improves the workability and durability of concrete while reducing carbon dioxide emissions. Slag. Slag is also a byproduct of steel production. Can also be used in a clinker substitute as a clinker substitute. It use reduce energy consumptions and emissions and enhance the durability of concrete. Calcined clay. Calcined clay is gaining popularity as a sustainable alternative to clinker. It requires less energy to produce and can reduce carbon dioxide emissions by up to 40%. By incorporating these alternative materials, cement plants can significantly reduce their environmental impact while maintaining product quality. Third point is energy efficiency and waste heat recovery. Improving energy efficiency is crucial for reducing the carbon footprints of cement production. Energy efficiency measures not only lower emissions but also reduce operational costs. Upgrading kiln technology. Modern kilns are designed to be more energy efficient than traditional ones. Preheater and pre preheater and pre-calciner technologies allow for the recycling of heat, reducing the need for additional fuels. Yeah. So as I said earlier, the temperature of kiln is 1400 to 1500 degrees centigrade. when it go for the coolant, the temperature downs up to 150 degrees centigrade. And then this heat can be recycled in preheater, and we use this heat in preheater for the mixing of the cement powders. Waste heat recovery system. Waste heat recovery system capture excess heat from the cement production process and convert it into electricity. This reduces the cement reliance on external power sources and lower overall energy consumption. Alternative fuels. Using alternative fuels such as biomass, industrial waste, and refuse derived fuel can significantly reduce the carbon footprint of cement production. These fuels often have lower emissions than traditional fossil fuels and contributes to the circular economy by utilizing waste materials. By implementing these energy efficiency measures, cement plants can achieve substantial reductions in both energy consumption and carbon dioxide emissions. Carbon capture, utilization, and storage. So, carbon capture, utilization, and storage technologies are emerging as a critical solution for reducing the carbon footprint of cement production. These technologies capture carbon dioxide emissions from the production process and either store them underground or convert them into useful products. Carbon capture. Carbon capture carbon dioxide at the source before it is released into the atmosphere is a key step in reducing emissions. Post combustion capture is the most common method used in cement plants, where carbon dioxide is separated from the flue gases after combustion. Carbon utilization. Once captured, carbon dioxide can be used in various industrial processes, such as producing chemicals, fuels, and building materials. For example, carbon dioxide can be used in the production of carbonated concrete, which locks the carbon dioxide into the material, preventing it from being released into the atmosphere. Carbon storage. When utilization is not possible, captured carbon dioxide can be stored underground into geological formation. This method, known as carbon, carbon sequestration, ensures that carbon dioxide does not contribute to atmospheric greenhouse gas concentrations. While CCU is still in the early stages of adoption in the cement industry, it holds great promise for achieving significant emission reductions in the long term. Reducing water usage and enhancing water management. Water is a critical resource in cement production, used in various stages of the process, including cooling, dust separations, and material preparation. However, the industry faces increasing pressure to reduce water consumption and improve water management due to growing scarcity of freshwater resources. In our plant, we store the water in our mines whenever we excavate limestone. So we store water in. There are many storage in our plant where we store our water. Come from rainwater also we store there, and all the way the main issue of water storage. So what we can do to store this water? Closed loop water system. So implementing closed loop water system in concern in cement plant can significantly reduce the water consumption. This system recycle water within the plant, minimizing the need for external water sources, and reducing waste water discharge. Rainwater harvesting, collecting and storing rainwater harvesting, collecting and storing rainwater for use in the production process and can further reduce the demand for fresh water. This approach is particularly beneficial in regions with high rainfall and limited water resources. Water efficient equipment. Upgrading to water efficient equipment such as high pressure nozzles. We use high pressure nozzles in our plants so that we can save water. We can clean the materials and things without using water through the high pressures. And advanced cooling system can further reduce the water wastage in cement productions. By adopting these water management practices, cement plant can minimize their impact on local water resources and contribute to global water conservation efforts. Embracing digitalization and Industry 4.0. The digital transformation of the cement industry, often referred to as Industry 4.0, offers significant opportunities for enhancing sustainability. By leveraging digital technologies, cement plant can optimize operations, reduce waste, and improve energy efficiency. Predictive maintenance. Using sensors and data analytics, cement plants can predict equipment failures before they occur, reducing downtime and improving overall efficiency. These proactive approaches minimize wastage and extend the lifespan of equipment. Process optimizations. Advanced data analytics and artificial intelligence (AI) can optimize the cement production process, reducing energy consumptions and emissions. For example, AI can adjust kiln temperature in real time to ensure optimal fuel efficiency and clinker quality. Supply chain optimizations. Digital tools can also optimize the supply chain, reducing transportation related emissions and improving resource efficiency. For example, AI powered logistics system can optimize delivery routes and schedules, minimizing fuel consumption and emissions. It also saves the time. By embracing digitalization, cement plants can achieve significant sustainability gains while improving operational efficiency and reducing cost. Implementing sustainable cement production standards. Adopting and adhering to recognized sustainability standards and clarification and certification is essential for cement plants striving to improve their environmental performance. These standards provides a framework for implementing best practices and achieving measurable sustainability outcomes. ISO 14001. This international standards specifies the requirement for an effective environmental management system (EMS). By achieving ISO 14001 certification, cement plants demonstrate their commitment to reducing environmental impacts and continuously improving their sustainability practices. Environmental product declarations. EPD. EPDs provide transparent information about the environmental impacts of cement products throughout their life cycle. By developing EPDs for their products, cement plants can meet the growing demand for sustainable construction materials and differentiate themselves in the market. Green building certifications. Cement plants can also contribute to green building certifications such as LEED, Leadership in Energy and Environmental Design, and BREEAM, Building Research Establishment Environmental Assessment Method. By, by supplying sustainable cement products, plants can support the construction of environmentally friendly buildings and infrastructures. Adhering to these standards not only enhances the sustainability of cement production but also improves the plant reputations and marketability.
अभी चार पांच स्लाइड है बता
Community engagement and corporate social responsibility CSR. Sustainable cement production extends beyond the plant's operations. It also involves engaging with local communities and contributing to their well-being. Corporate social responsibility initiatives play a vital role in building positive relationship with stakeholders and enhancing the plant's overall sustainability. There is a separate team of CSR in our plants, in cement plants, to do a good work to save the environment. They are doing plantations, they are doing cleaning, they are making storage in nearby areas of the plant for the sustainability. Community development programs. Cement plants can invest in local community to development programs such as education, healthcare, and infrastructure projects. These initiatives improve the quality of life for residents and demonstrate the plant commitment to social responsibility. Environmental stewardship. Engaging in environmental stewardship programs such as reforestations, habitat restorations, and biodiversity conservations helps offset the environmental impact of cement productions and enhance the plant's sustainability credentials. Transparency and reporting. Regularly reporting on sustainability performance through sustainability reports and stakeholders engagement helps build trust and accountability. Transparency in environmental and social practices ensures that the plant is held to high standards by both the community and regulators. By prioritizing CSR and community engagement, Cement plants can create a positive social and environmental legacy, reinforcing their commitment to sustainability. The future of sustainable cement productions. The cement industry is at a crossroads, with sustainability becoming an increasingly critical factor in its future. As environmental regulations tighten and customer demands for sustainable products grow, cement plant must continue to innovate and adopt sustainable practices like research and development R&D. There is a separate team of R&D in our plant. In I think in all the cement industries, ongoing R&D efforts are essential for developing new materials, technologies, and processes that further reduce the environmental impact of cement production. Investment in R&D will drive the next generation of sustainable cement products and production techniques. Collaboration and partnership. Collaboration with government NGOs, academia, and other industries is a vital for advancing sustainability in the cement sector. Partnership can accelerate the development and implementation of sustainable practices benefiting the entire industry. Circular economy. The circular economy presents significant opportunities for the cement industry by embracing circular principles such as recycling, reuses, and resources efficiency. Cement plants can reduce waste, lower emissions, create a more sustainable production model. The, the future of cement production lies in sustainability, and those plants that leads the way will not only reduce their environmental impact but also gain a competitive edge in the market.
Hello, it is not audible.
Yes, ma'am. Conclusions. Sustainable cement production is no longer an option, it's a necessity. The techniques and practices outlined in the guide provide a roadmap for cement plants to reduce their environmental impacts, improve resource efficiency, and lead the industry towards a greener future. By embracing alternative raw materials, energy efficiency, carbon capture, water management, digitalizations, and community engagement, cement plants can achieve significant sustainability gains and secure their place at the forefront of the global green economy. As the world continues to prioritize sustainability, the cement industry must rise to the challenge, adopting innovative practices and technologies that reduce its carbon footprints and contributes to a more sustainable future for all. By implementing these sustainable cement production techniques, your plant can not only meet the demand of today's environmentally conscious market, but also position itself as a leader in the industries transitions to a more sustainable future. This approach will ensure that your cement production process are not only efficient and cost effective, but also aligned with the global goals of reducing carbon emissions and conserving natural resources. Thank you.
Question from audience participant. Any question from participant? Hello? Is it audible? Hello?
Yes, yes, it is audible.
Any question from participant? No question? Mm. Sir, one question is given in chat box. Hello?
Okay, ma'am. Okay.
Sir, are you visible? In chat box it is given the concept of PPC which pliers is based is used has gained significant importance, but why the use of slag cement has not gained much importance, and why are blended cement not being manufactured by using other cementitious material?
Okay, so the question is the concept of preparation flies. Okay, generally the slag-based cement generally not use. The reason is in slag, whatever the you can if you consider steel slag, the problem with steel slag is the iron content as well as the free lime and free calcium oxide content. Due to which what happen now if you use in cement, it is having a possible chance of means expansion of volume in future, so which will create problem for structural purposes and as well as which form cracks in future. So that is the only reason slag is not used in the cement, but research is going on till now. Many companies like Tata and other companies they are doing and they are going for slag based cement. Still research is going on, so it will happen very soon. And similarly, why other cementitious materials are not used, that is the only reason that in fly ash, because whatever the nature of fly ash, the calcium oxide content as well as silica content is having the similar that of cement. So that's why generally fly ash is used. So other cementitious material are also the research is going on, and very soon you will get to see that other cementitious material can be used in cement. Thank you.
Am I audible, sir?
Yes, ma'am.
Sir, I have one question that what is the effect of steel slag on concrete properties and how it affects?
Okay. So steel slag generally right now, if you check, various type of steel slags are there according to its production process. Okay, so we can say in India, if you check the BOF type, that is basic oxygen furnace type slag, is generally available. Other slags are also there like EF, electric arc furnace slag, LD slag, many are there. So the slag is having, like, if you in slag generally right now in India, they can be used in cement, but not that much explode yet. But people are generally going for as a coarse aggregate slag. So why the reason is the coarse aggregate alternate, like for alternate coarse aggregate you can use it in concrete, and they are far better physical as well as mechanical properties than compared to the natural coarse aggregate. But the only problem is that is the iron content as well as the free calcium and our free calcium and iron content. Okay, so that can be reduced by very many processes are there like weathering and carbonation you can do. And if you do, and if you able to reduce that content of free iron as well as calcium, that can be easily used. So nowadays, have you got the information or not that India have already made a steel slag road in Surat, and that is for around 2 to 3 kilometer, and India is planning for reducing the natural coarse aggregate for road purposes only, and very soon it will be used for concrete purpose, like for building purposes only. So slag can be used, but the only problem is that you have to first, before using, you have to process that slag. Means direct slag you cannot be used, like because of that iron content. Now if you use indirectly in like if you mix in concrete, or as well as if you replace as a cement replacement, so the due to the iron content, the expansion issue will happen. Okay, and that is the only reason people are not using. But after processing, it can be easily used in concrete, both like you can use as a coarse aggregate as well as a cement replacement, and both are giving comparable as well as better result than the conventional concrete. So many studies have been done, and many are right now going on also. And let's see in future, it may happen like you can easily use slag whatever in cement as well as in coarse as a coarse aggregate in concrete. Thank you.
Okay, now I request to Nihar Ranjan Mantha, please introduce to sir today's speaker.
Okay, ma'am. Thank you, ma'am. A very good evening. A very good evening to the esteemed delegates, respected faculty members, and participants. It is an honor to introduce our distinguished guest, Dr. Daniti Saradhi Babu, who currently serves as a technical manager, concrete specialist, Alliance Concrete Singapore Private Limited, Singapore. He has completed his MS from Indian Institute of Technology, Madras, and PhD in Structural Engineering at the National University of Singapore. He has over 20 years of professional experience in the area of concrete technology, ready mix concrete, research and development, teaching, training, construction with strong academic background in civil engineering, ready mix concrete, cement, and concrete materials, new product development, specifications, quality control, controls assessment, including non-destructive testing, use of sustainable methods towards development of low embodied carbon products. With due respect, I now invite Honorable Dr. Daniti Saradi Babu sir to kindly deliver his speech.
Yeah, thank you. Thank you for nice introduction. Thank you for arranging, inviting me to give a talk as part of your faculty training program. It is my pleasure. So without further ado, we directly move on to the topic for the today's presentation. Hope you all see my slides. Are
It
you
is
able to
visible. It is visible. Sir, full screen.
full screen? Is it are you able to see?
Yeah, it is visible.
Maybe just I will scroll few slides whether it is moving or not. So then I will come back to the first slide. Okay.
Okay, sir.
Are you able to see the next slide?
No, sir, it is not changing.
It is not changing, is it?
Yeah.
Okay, because it is the same thing happened at other
Other
presentations.
organizers. Okay.
Yeah, so that's why I what I do, I don't go for the full screen. Then I will just go slide by slide in the presentation itself. Okay.
Okay. Okay.
This slide you are able to see, right?
Now, yeah, now it is changing.
Okay. Okay. So maybe we just go by slide. Okay.
Okay, sir.
Okay. So thank you all joining for this lecture. Basically, my topic is design for durability and sustainability in concrete construction. Okay, so I will start with a brief introduction first on cement and concrete materials, why we have to focus on sustainable materials, low embedded carbon products, and what are the ways which we can consider to reduce the concrete waste. And I will touch on some special products here and there. Okay, so after that, I move on to durability and service life of concrete constructions. Okay, and design for durability and sustainability. I will show you here and there some applications and examples in projects, especially in Singapore scenario. Okay, and at the end, I will give you some details about a statement of a problem for a project proposal and why R&D is important. So hope some of you are doing R&D, as well as some of the PhD students and master students. They might be planning to do their presentations and proposals and things like that for their degrees. And at the same time, faculty members, basically always there is a grant calls from the government organizations. When you have a grant call from the government organization, basically you have to see what are the strong key areas of your specialized research. Based on that, the key deliverables suit to the required proposal. You may have to do a proper a proposal to attract the funding agencies to allocate some fund to your proposal. So I will give you some brief details what are the key factors you need to consider. Okay, so let's move on to the directly the introduction. So you all know what is cement paste, what is mortar, what is concrete. Basically cement paste is nothing but cement and water. Sometime it will have admixtures. It depends on what kind of application you are looking at. So sometime you may have to consider the required admixtures to achieve the required workability and placeability for the actual usage. So mortar is nothing but adding sand to the paste become a mortar. Concrete is actually adding a coarse aggregate to the mortar. Basically the combination of all the cementitious material, water admixture, sand and stone basically gives you the concrete. Okay, so concrete is actually one of the most widely used building material in the world after water, because of its any shape and all the things can be created because of its beauty, strength and durability, among other benefits. These are the main benefits when it comes to the concrete. Okay, so if you look at the materials research, especially on the cement and concrete, you have so many areas. Okay, because every component will give you a scope to come up with a research proposal and things like that. Okay, sometime you may need to understand more about the microstructure of the concrete. So in order to understand the microstructure of the cement paste and concrete, you may have to have special testing methods. So that special testing methods may be different from what currently existing. Okay, so likewise you may need to understand the cement chemistry behind it, what is happening. And there are different cementitious materials which we need to consider as well, because later on I will show you why we need to use cementitious materials instead of those ordinary Portland cement and things like that. So on top of that, those are actually part of the sustainable materials. Okay, so use of recycled materials like byproducts, alternative materials, all those are sustainable materials. I will show you some examples later on. Okay, so the admixtures also, different applications may require different kind of performance criteria, workability and the strength development and setting time controls and things like that. And fibers in concrete also nowadays getting popular, because fibers helps to minimize the cracking tendency. At the same time, once you are controlling the crack, it means the durability of the concrete will be enhanced as well. So you can work on like other special materials like lightweight materials and aggregates and things like that. So concrete is actually a very huge area, have a lot of potential areas for the research. Okay, so yeah, these are the items. In fact, some of the things I have covered. If you look at the cement related problems, CO2 emissions are actually one of the huge problem, because the liberation of CO2 is like almost like 1 ton of cement production liberates almost like 1 ton of CO2. Okay, so that is the reason why we have to depend on huge replacements, high replacements of cementitious materials. Okay, so which can be like conventional existing materials like fly ash, silica fume, GGBS and those kind of things. Or otherwise we may have to work on natural pozzolans. Okay, so like those metakaolin nowadays, actually there are new kind of cements and all those also available in the market. Those are basically made from the sustainable materials. Okay, sometimes it can be from the waste, sometimes it is a natural material, but it has reactive properties and things like that. Okay, so and also we have to give priority to the durability of the concrete, because when we design a concrete structure for 50 years of service life or 100 years of service life, we have to use the required performance criteria also we have to consider when we come up with a mixed design for a specific construction. Okay, and always you have to think about the cost also, how to optimize the project cost at the same time fulfilling all the required performance criteria and things like that. Okay, so why we have to go for low embedded carbon products? Okay, because buildings are currently responsible for 39% of global energy related emissions. 28% is from operational emissions. Operational emissions are basically the emissions after the construction of a project. So in terms of energy related needs for heating, cooling, okay, to power them, we have to use a lot of energy. Okay, so the remaining 11% comes from the materials and construction. So this part is actually, we call it as a embedded carbon. So these are all the 11% of the materials up to the construction. Okay, so beyond, after construction, during service life, the emissions will be involved as the operational emissions. Okay, so but when it comes to the, even though the embedded carbon looks a small amount, okay, compared to the operational emissions, but the huge stock of constructions are involving to cater for the increased population and all the things. So that is the reason why we have to give priority. Okay, so some estimates says that towards the middle of the century, as the world population approaches 10 billion, the global building stock also expected to be double in size, which means we may expect a substantial amount of embedded carbon emissions apart from the operational emissions, which we as a civil engineer, as a material researcher, you may not able to control the operational emissions. Okay, but you can give priority to control the embedded carbon related emissions. So therefore the building environment sector has a vital role to play in responding to the climate emergency and addressing the upfront carbon, which is a crucial and urgent focus. We have to give priority to it. Okay, so what are the typical impacts when you have high CO2 concentrations currently, which we are already experiencing, is climate change. Okay, having air pollutions, the quality of the air is no longer there like olden days. The atmospheres also more and more nowadays we are feeling even very hot summers and things like that, the global warming. And also we don't have specific pattern of weather scenarios nowadays. So anytime can rain, anytime can shine like that. Okay, so all these actually making the planet's ability to support the a life severely. Okay, so all these resulting in drop in agricultural yields, creating a lot of deaths, especially the animals and things like that, the increased occurrence of diseases in the planet and animal world. So these are all why, because of the high CO2 concentrations in the earth atmosphere. Okay, so where these emissions comes from when it comes to the cement and concrete industries. Cement is actually one of the fine powder. Basically it is a soft powder used as a binder because of its hardened properties and things like that. Okay, when it is mixed with water. Okay, it is produced from a mixture of limestone and clay, that basically charred and then ground up. So when you use these materials, like here you can see like limestone and clay, these are the natural materials. Okay, so you need to mix them properly. Okay, after you grind to the fine powder, and then you have to fed through the rotary kiln. When you feed through the rotary kiln, which involves like 1450 degrees Celsius temperature, so the material will be converted into a clinker in the form of like CaO plus CO2 liberate. That process, in that process basically there is a huge amount of CO2 liberation will takes place. Okay, so on top of that, basically the transportation of the cement to the construction sites, then we use a lot of natural resources like aggregates and things like that to produce concrete. Okay, even though subsequent emissions are not so huge, but the cement production create a lot of emissions when it comes to the CO2. So in the concrete in the cement and concrete industry, basically 90% of the emissions comes from the cement manufacturing process itself. Okay, so that is the reason why cementitious supplementary cementitious materials plays an important role. So if you look at the sustainable development diagram, it is a Venn diagram. Basically the sustainable development is nothing but the development which meets the needs of the current generations without compromising the ability of future generations to meet their own needs. So we have to give priority to the environment, at the same time the social as well as the economic scenarios as well. Okay, so when you use supplementary cementitious materials, actually you can reduce cement the CO2 emissions substantially. Okay, later on I will show you some numbers and examples. You will understand how significantly we can reduce the CO2 emissions, okay, with the use of supplementary cementitious materials. So again, these supplementary cementitious materials are byproducts from other industries. Sometimes we will use the available natural soil or things like that to convert into a natural pozzolans and things like that. Okay, so once it is a byproduct, it is become a waste. Once it is a, if there is no application to it basically it takes up some place for land filling and things like that. Okay, so that again basically pollute the soil as well as the groundwater and things like that. So as long as if you have a usable application to the supplementary cementitious materials, that increase the cost of the waste product as well at the same time. Okay, so nowadays people are talking about carbon capture and utilization. Okay, so the carbon capture, storage and utilization technologies which are getting popular. Okay, I saw one of the schedule, one of the Canadian speaker might have introduced about the carbon cure, okay, in the faculty development program. Okay, so in this carbon cure, basically they pump the CO2 into the concrete during the mixing into the mixer itself. So there basically there is a reaction between the CaO and the CO2 produce a calcium carbonate, which is they call it as a like a mineral that basically trap the CO2 and it doesn't release into the atmosphere. So in such a way basically we can reduce the global atmospheric CO2 emissions with the concrete production. So what basically in this technology they do is, because every industry, especially the factories and the data centers and things like that, they produce a lot of CO2 in the process. Okay, even the cement production just now we have discussed in the earlier slides. So as long as you capture these CO2 and treat to the required quality to use it as a recycled CO2 during the concrete production, like carbon cure technology and things like that, you can reduce the CO2 concentrations in the atmosphere, whereby you can contribute to enhance the quality, air quality and things like that. At the same time, this CO2 when it react with concrete, it basically enhance the properties of the concrete as well, like some improved early strength and things like that. Okay, so I don't go into the details. Basically you can actually go to the carbon cure website to find more details if you are interested to learn. Okay, so again, as I mentioned, there are a lot of researches are ongoing worldwide. Some are actually trying to pump in the CO2 into the recycled aggregates to understand the potential of the absorption levels and things like that. Okay, and some in fact are trying to pump into the recycled waters and things like that to enhance the I mean recycled water, once it is actually having some kind of parameters that can react with CO2 and produce some useful minerals as well. It can be used as a enhanced strength enhancer like that in some of the scenarios. Okay, so again, as I mentioned, basically there are some researches ongoing. They are trying to pump the CO2 into water as well as the recycled water, and those actually the recycled ready mix concrete slurries and things like that. When you are having ready mix operations, always there is a a lot of washing water and things like that. So those wash waters and things like that can be treated and used to certain extent when you use these kind of technologies. Okay, so if you look at the aggregate related problems, as I mentioned, basically every component in the concrete can be one of the research area. Okay, so now in order to produce huge volumes of a concrete, you need to have a lot of materials, so there is extensive mining and things like that. So those basically pose environmental concerns, basically the erosion and ground settlements and things like that. So the depletion of natural resources, so future generations may have to see some of the natural resources in the museum if we keep on digging. Okay, so that is the reason why we have to find alternative materials. So there are abundant waste and alternative materials or byproducts from other industries. As long as you use them as a supplementary replacement of the aggregates and things like that, you can avoid relying on natural resources to certain extent. Okay, so again at the same time you have to see the source for and develop new cementitious materials. And again if you are having a waste, you have to find the place for dumping, become a illegal dumping that actually spoil the nearby environment and things like that. So if you look at the aggregates, there are different type of waste available in the industry. Okay, like steel slag, ceramic waste, brick waste, recycled aggregates, waste glass, e-waste. There are many. Okay, so like coconut shells and all those kind of things. Okay, so if you are actually, I mean, for the academicians, they are always have to mingle with the nearby industry. It can be a construction industry, it can be a agricultural industry. If they are having waste, how to help them, and how to come up with some kind of solutions to them. These are all become potential areas for the research to solve the issues at that particular region and the particular provinces. Okay, so if you look at the natural resources, if we keep on relying on river sand and things like that, there is always like erosion and things like that happening because of this the dredging of sand and taking the sand from the natural sand from rivers. So we have other substitutes like crushed granite fines, or otherwise whatever the aggregate crushers they use. It can be a limestone fines or whatever the aggregate nearby available. Those materials can be used as recycled fine aggregates as replacement aggregates to the natural sand, so that basically lessen the impact and relying always on the natural sand. Okay, so there are some examples later on I will show you. When it comes to Singapore scenario, we are accepting even up to the 100% of granite fines for constructions. Okay, so how the granite fines can be used? It can be used like natural sand, but if the rheology of the matrix and things like that, you need to do some modifications in order to achieve the required workability. You may have to consider additional admixtures or additional cement contents and things like that to achieve the required performance and properties. Okay, so that is the reason why we have to see what are the other alternative materials available. So you have to assess the quality, you have to assess the performance with respect to the natural aggregates. Then you can actually come up with some recommendations and guidelines to the people or industry, whereby they can adopt the solutions. So who can give the guidance and all? Only the institutions like you, NIT, IIT, and the research centers have to provide useful information to the industry by come up with sometimes research followed by some pilot projects, sometimes assessing the long-term performance. All those basically you have to document it, present in the conferences, and publish here and there. Those will create awareness. Then people start thinking of using, especially the industrial collaborators. They may come and approach you, can you give us the solution? So they may give you some research funding to expand the research and things like that. Okay, so when it comes to the use of granite fines or the manufactured sand which I have mentioned, there are researchers was done earlier before come up with the recommendations in the local industry. Okay, so you can actually go with 100% replacements, but if you need to do fine tuning of the recipes and things like that, basically you have to consider what kind of modifications are required. Okay, so when it comes to the performance, even with 100% replacement also, the porosity and the water absorption and things like that have not much of an impact, as long as you control the workability by doing necessary modifications. Okay, so if you look at other details, just now I mentioned basically granite fines. Okay, so the use of granite fines, currently in Singapore, we are moving one of the current existing mega port, okay, the terminal, from the center of the Singapore to one side of the Singapore. So here I cannot pull the laser to show you, but you can see this green arrow in the right side of the map, whereby the shifting of the port is happening from here to here. It is going to be operational from 2030 onwards. Okay, so for this port construction, we need to produce caisson sea walls. Those caisson sea walls basically huge, later on in the next slide I will show you the dimensions of the seawall. These sea walls are produced and placed into the sea, and these compartments are filled with other kind of materials, then construct a port at the required location. Okay, so basically in this project, in one project, in both the projects in fact involved like 1.5 million meter cube of concrete volume, and in one project we used actually 100% of granite fines. Okay, but it is very challenging because when it comes to Singapore, all the aggregates have to be imported. Not only aggregates, all the raw materials, in fact we import from the neighboring countries. Okay, so it is very challenging to use 100% for the huge volume of concrete. So in the next project, because of the challenges, not able to get sometimes the shipments on time and things like that, we reduce the usage to 50%. But in Singapore scenario, now there is a Singapore standard, the SSEN 206, which is the concrete standard. It allows use of 100% granite fines for the construction. Okay, so which means basically you are eliminating completely. If you are going with 100% granite fines, you are saving the 100% of river sand, so you don't need to depend on the river sand, especially when it comes to the production. Okay, so this is the caisson wall. You can see the dimensions. It is a 40 meter by 28 meter by 28 meter. Okay, the height of each caisson wall. It is a non-stop a slip form based construction done by the South Korean team, Delim Construction, as well as the Hyundai. Okay, so the slip form construction requires a special kind of concrete, because it is a non-stop casting. Concrete always will be placed on into the forms, and over the slip forms are every 20 minutes they will jack up. Okay, which means the concrete is already set, the previously placed concrete already set below. They will lift up the forms slowly by 20 centimeter 20 centimeter, like that. It is a non-stop kind of casting. So when you are dealing those kind of projects, basically you need to have a very consistent quality of the materials. At the same time, you need to have a very robust admixtures and things like that. Okay, so these are all some of the areas if you are really dealing with the come up with the solutions to the end user, you can consider. Okay, so this is the caisson wall which I mentioned. It is something like a 28-meter high wall, and it is actually constructed with a slip form method. Okay, so here the first phase of the terminal was constructed by the Hyundai's team, whereas another one is actually by Delhi. Both are also South Korean contractors. Okay, so on top of that, when it comes to Singapore scenario, we have a shipbuilding industry. To blast the basically you need to do the maintenance of the ships, so the ship surface and all those things you need to do periodical maintenance and all the once a while. So when you do periodical maintenance, they use basically a copper slag. They bring the copper slag, they spray onto the those ships and hulls. All these will actually deposit into the sea. So this waste is also accumulating in the sea. So this waste basically we excavate, we do the treatment, and we use that as a fine aggregate as well in Singapore. Okay, so in the Singapore construction, they allow replacement of this material up to 10% of fine aggregate. Okay, so on top of that, coarse aggregate, recycled coarse aggregate. So we actually, whenever we have a demolition of the buildings, produce lot of coarse aggregate. So here we have a demolition protocol which we follow similar to the UK practices. Okay, so you have to isolate all of your concrete chunks to one side and other kind of debris to another side. So all these hardened concrete and the big chunks of concrete go to the recycle plants. They try to separate the aggregates from the rest of the mortar and things like that. And the concrete, the aggregate quality, again you have to assess, and you have to comply to the standard. So when it comes to Singapore SS 12629 12620 is the aggregate standard. Okay, so you have to produce the recycled aggregate quality to comply to that standard. So in Singapore scenario, we allow up to 20 to 30% of recycled concrete aggregates to replace the natural crushed granite or whatever the aggregate. In Singapore, everything we import from neighboring countries. So for structural concrete applications, we use only one kind of aggregate. It is a granite aggregate. Okay, so we don't use any other aggregate. But currently now, if the granite aggregate is not available, what is the next option? Like that, we are doing some research on limestones aggregate also. But when it comes to the usability of the limestone, it is not new. It is already being used everywhere, wherever it is abundantly available. But for the local scenario, we want to do some R&D. So currently there are some research funding by the government to the universities. They are doing some research on this. Okay, so if you look at how to minimize the waste. Okay, so in Singapore, we use concrete reclaimers. You can see the below one is a reclaimer. It consists of two compartments. One side is the coarse aggregate, whereas another side is the fine aggregate. So if there is a waste concrete come to the plant, or any excess concrete come to the plant, they don't dump. We try to wash the concrete with more water, and we throw into this concrete reclaimer. This reclaimer basically will separate the concrete sludge as well as the fine aggregate and coarse aggregate. There are some screens internally within the concrete reclaimer which separates the materials. So the reclaimed materials can be used in the construction, similar to the the original materials. Okay, reclaimed aggregates are just washed materials only. Okay, so on top of that, what are the other things which we have locally? We all the ready mix concrete plants have to be certified under SSEN 206 by the Singlas accredited certification bodies. Okay, so if it is a standard concrete like grade 30, M30 to M60 in Singapore, in India, a designation scenario, we have standard certified products from M30 to M60. So whoever want to order the concrete, they can actually place the order without having a pre-assessment on the quality and things like that, because these are all like a off-shelf items they can directly buy because the products are already certified. Okay, and we are also trying to currently the site practices are 150 cube as the sample. You need to do the prepare the samples for the strength assessment of the concrete whatever being delivered to the site. And some of the government agencies already started being using like 100 cubes. Okay, so when you use 100 cube, actually you require less concrete, and after testing, the waste generated from the testing also will be lesser. So that is also one of the sustainable way to minimize the waste. Okay, so on top of that, which I already discussed, number 3 is the reclaiming of the aggregates from the waste concrete. Okay, so these are all the certified products. How it looks like, as I mentioned, it is the M30 to M60. 60 we follow a global unified definition. C strength class C25 by 30 means 25 is the cylinder strength and 30 is the cube strength. In India we follow M30. M30 is nothing but it should be a cube strength. Okay, so this is the unified definition, but in Singapore we still practice cube strength only for the cube strength assessment, strength assessment of concrete, similar to the UK practices. We don't use cylinders like US they follow cylinders as the criteria. So when it comes to the definition of strength class, they will still use C32 by 40 or 25 by 30 for example. And they will when they do the strength assessment of the cylinder, they will verify against 25 instead of 30. We practice cube, so we have to verify and comply for the 30 if we refer to the M30 concrete or C25 by 30 concrete. Okay, so what are the other materials? So just now I mentioned basically secondary raw materials can be used in the construction. It can be aggregate alternative material, or it can be a cementitious alternative material. Okay, so if these are the byproducts from other industries, basically if they don't have any value, become a negative value, because you need to pay somebody to come and collect the material, so you need to pay, become a negative value. But when you find the application to the material, they will come and pay you to collect the material. Okay, so that is called creating a value to the waste. Okay, so the cost associated with disposal and land fillings can be eliminated. At the same time, the supplementary cementitious materials which I just now mentioned, I will show you some examples later on. Okay, so those basically will enhance the concrete performance in terms of workability, strength and durability, and also reduce the environmental impact. Basically the CO2 emissions and all the things can be lowered. At the same time, it reduces energy needs. Okay, so energy needs, how it will reduce, basically you don't need to produce so much of clinker is nothing but a ordinary Portland cement, because if you use a ordinary Portland cement, it consists of like 95% of the clinker, 5% of other additions. Okay, so when you have a clinker, when you produce a clinker based on the ordinary Portland cement production system, it will generate a huge amount of CO2 emissions. Okay, so we follow the BSEN and BS practices and standards. So our cement standard basically SSEN 197-1, which allows cementitious materials as the main constraints in cement production. Okay, so what we do locally, we bring OPC separately and GGBS or fly ash or whatever the silica fume separately. We mix inside the ready mix batching plants together to achieve a required type of cement, and we produce the concrete based on that. Anyway, just now I mentioned fly ash. When it comes to fly ash, we don't import any fly ash because fly ash is actually comes from the thermal power plants, and we don't import other country waste into our Singapore, but we still import GGBS abundantly, and we use huge amount of GGBS and silica fume locally. Okay, so when it comes to fly ash, like India, China, they produce a lot of fly ash. It can be used if it is available locally, and fly ash is also one of the well proven material when it comes to the long term durability and things like that. So how these will help? Basically, use of supplementary cementitious materials helps to reduce the energy needs and CO2 emissions, those greenhouse gas emissions substantially. Okay, so based on the replacement levels, if you use higher replacement levels, the reductions in terms of the CO2 emissions become more and more. Okay, so what are the Singapore practices locally? As I mentioned, we have a concrete standard ESSEN 206. We have aggregate standard SSEN 12620. These two standards encourage the use of uh, other kind of materials for the concrete production. Okay, so we have since 2005 we have green concrete usage and green concrete practices locally, and in fact we already have a few versions of revisions and improvements all the way from 2005 to 2021. Now we are following currently the green mark. BCA is nothing but Building Construction Authority Singapore. Okay, so they always come up with guidelines to the industry. Okay, so based on the current guidelines for all the new constructions, now you have to do your whole life carbon assessment. Why we need to do all this? Because we support the Paris Agreement 2030 and 2050 net zero emissions and things like that, and we guide the industry people basically with the specifications and guidelines from the government to reduce the CO2 emissions as much as possible. Okay, so that's why they initially the practice is actually try to use the recycled materials and the green materials only, but at the same time now we are looking into the numbers, what kind of carbon assessments which we are looking at. By adopting these kind of green practices, what are the numbers we are able to achieve in a given a specific project. Okay, so we have targets like we need to reduce by 2030 and 2040. Likewise, there are certain benchmarks government already set, so we are trying to implement as green materials as possible. So if you look at the green carbon emissions, they have the carbon emissions from concrete, glass and steel, their target is actually reduce more than 10% or more than 30%. So if you reduce more than 30%, government will give you more incentives and co-funding to the project. Okay, so in that way they are encouraging the construction teams and industry to encourage adopt the more sustainable and green practices. So if you look at the right side, design with low CUI, concrete usage index, means for a given constructed floor area, if you use less concrete volume, basically to achieve the similar kind of performance and load carrying capacity and things like that. Okay, so you will get more green mark points. So likewise, adoption of some sustainable building systems, like other kind of designs like hollow core slabs and those whatever the new system that you are trying to propose for the construction, as long as it is actually sustainable and it will reduce the waste generations, at the same time it will fulfill the design criteria and things like that. Okay, they will welcome. So the construction industry, especially the building and construction authority Singapore, welcome the construction teams. Okay, so likewise, if you look at the use of low carbon concrete, so now we are going with the SEM22 cements to SEM5 cements. Okay, later on I will show you some details what are these SEM2 and SEM25. Okay, so which means SEM2 is nothing but you have to use more than 20% of the uh, again the SEM2, you have to see what is the a type of material and things like that, but majority when it comes to local scenario which we use GGBS only. So when it comes to GGBS, in order to have a SEM2A up to 20%, SEM2B up to 35%, SEM2 SEM3A up to 65 percentage, SEM3B if you use in terms of the GGBS replacements up to 80 percentage. Okay, the dash 5 is actually the SEM5 is more of a composite cement kind of thing. So in order to produce a low carbon concrete, you have to use certain amount of supplementary cementitious materials, then only you are able to qualify for the low carbon concrete certified product. So we have some requirements. Okay, so Singapore Green Building Council, in the short form SGBC, they rate the concrete based on the clinker content involved, based on the replacement levels involved. Okay, so on top of that, as I mentioned, basically the use of recycled concrete aggregate and washed copper slag and granite fines are part of our specifications, which we use huge quantities to minimize the usage of natural materials. So here you can see something like we have if you go to the electronic shop to buy a refrigerator, you always see how many energy tick saving, 2 tick, 3 tick, 4 tick, how many tick. Likewise we have even for the concrete as well. Okay, so SG, the Singapore Green Building products, 2 tick, 3 tick, 4 tick. Okay, so if you are having 4 tick means that is actually more recommended, which can gives you the lower embedded carbon emissions. Okay, which means it consists of high amount of supplementary cementitious materials. Okay, so likewise, again as I mentioned, we have certain minimum requirements when it comes to recycled concrete aggregates. You have to use at least minimum 20 percentage like that. Okay, and when it comes to the water wash copper slag, that is actually in fact maximum replacement. Here there is a typo error. Okay, and when it comes to the granite fines, you have to use at least like 50 percentage to 100 percentage range. Okay, so if you use less than 50 percentage, you may not able to get a certain number of green mark points. Okay, so if you look at the admixtures, again as I mentioned, admixtures, every component of the concrete is actually one of the research area. So based on the type of project, sometimes you may have to have different kind of requirements. Sometimes you need to have accelerators to achieve the early strength. Sometimes you may need to have consistent setting times and things like that, as I mentioned earlier, when it comes to slip form construction. Okay, so likewise when it comes to the admixtures, it is a very big research area as well. So now you all know self compacting concrete. There is a background noise, maybe someone can you please mute. Okay, so when it comes to the self compacting concrete, basically you have to use specialized new generation admixtures.
अब कौन किसका है नाम देख लो यार अभी देखो गैस वाला तो ऑटोमेटिक हो गया है तो आपको किसको देखना है जो ब्लैंक है उसको सेलेक्ट करो केवल तो उसे ब्लैंक वाला आ जाएगा अभी पढ़ लो
maybe the moderator can mute the other
यादव है मेरे ख्याल से ऋषभ यादव तो ही देख लो.
Okay, so when it comes to the self-compacting concrete, as I mentioned, basically the main development of self-compacting concrete is if you use a conventional concrete, basically the challenge is the compaction of concrete to have a uniform compaction of the concrete with good surface finishes and all. Okay, so if you use a non-suitable and non-workable concrete, you will end up with honeycomb. You need to do a lot of rectifications. Those basically will influence your durability and things like that. So the self-compacting concrete, the objective is basically consolidate the concrete by itself in the forms fully. When you remove the forms, the surface finishes must be surface finishes will give you very complete compacted finishes without having any honeycombs and voids. So that is the main objective of developing the self-compacting concrete by the Japanese team. Now in fact when it comes to Singapore scenario, we are using in a different manner. Even though we are trying to enhance the surface finishes, at the same time it doesn't require manual compaction. You don't need to use the manual compaction. So which means if you use self-compacting concrete, you don't require additional manpower to do the compaction. So because when it comes to Singapore, we always have manpower issues. We have to bring in manpower from the foreign countries, especially the general construction scenario. So when you use self-compacting concrete product, basically you can use less manpower. That is actually enhance the productivity, and you can go with faster construction and things like that. Okay, so let's move on to the concrete specifications which I mentioned just now. Okay, a design for durability scenario. When it comes to the durability, you all know the definition of durability. Basically concrete has to act like a defense shelter. Okay, it has have a ability to resist weathering action, chemical attack, abrasion, or any other process of deterioration, because concrete tends to deteriorate. But if you don't have a proper recipe, proper control on the cement type or water cement ratio and minimum cement contents and things like that. Okay, so that is the reason why when you commence a project, you need to have a properly written specifications. So when you send the specifications to the tender stage, whoever bidding for the project, basically they have to review the specifications and they have to plan their bidding amount and things like that based on the required performance. Okay, so when it comes to the durability, when it comes to the design for durable structures, we always go by the two approaches. One is the prescriptive approach, another one is the performance based approach. In the prescriptive approach, basically we have to follow minimum cement content, maximum water cement ratio, and strength class and all those kind of things. Whereas when it comes to the performance based approach, that is completely different. As long as you achieve the required performance to cater for the long-term durability or any rapid chloride permeability and things like that, you don't need to set minimum cement contents and things like that. So this performance-based approach is actually becoming popular in the new specifications. Okay, so when it comes to the durability of concrete structures, it can be improved by using low water cement ratios, increasing cement content, providing greater concrete cover, selecting more durable cements and things like that. Okay, so for the design for durability, in the prescriptive specifications, this is the extract from SSEN 206. For 50 years of service life, basically we follow different exposure classes, because concrete structure may be exposed to different scenario. It may be a factory environment, it can be like a chemical pollutant environment, it can be like a chloride environment, water environment. Different environments may give you different kind of degradation mechanisms when it comes to the durability. So you need to maintain certain quality in terms of the water cement ratio, in terms of strength, in terms of minimum cement content and things like that. Okay, so when you use high durable cements, the required levels and all the things can be reduced. Later on I will show you some details. Okay, if you look at the concrete quality, again you need to control within the concrete the chloride content. How much is the estimated chloride content? How you can estimate? Basically you have to know the chloride content of all the constituents involved in the in a given mix design for 1 meter cube. So these chloride contents you need to control when it comes to the reinforced concrete uh, structures. Okay, for the structural concrete you need to limit your chloride content to 0.2 percentage by weight of the cementitious content. Okay, but when you are dealing with the pre-stressing and those post-tensioning kind of scenario, your chloride content is limited to 0.1% only. Okay, so in terms of expressing the chloride class, basically we go with the Cl 0.2 for reinforced concrete, whereas Cl 0.1 for pre-stressed concrete construction. But when you use a durable cements like SEM3 type of cements, those GGBS contents more than 36 percentage to 80 percentage, you can actually go with higher chloride contents because those cements are more durable cements. When you use a durable cement, in fact you can use slightly higher chloride contents, almost like double the chloride contents. You can go for higher chloride contents. Okay, so as I mentioned, the durable cements, ordinary Portland cement, sulfate resisting Portland cements are in fact those are the low durable cements compared to those SEM2 type, 3 type and composite type of cements. Okay, so this one is extract from SSEN 197-1. Okay, so this SSEN 197 consists of two tables. One table they talk about general cements. Okay, whereas another table they talk about sulfate resisting Portland cements. Nowadays, cement producers are not producing sulfate resisting Portland cements because those are actually, they may delay the sulfate attack and all the things to a certain extent, but those are not as good as and as effective as SEM3 type of cements. SEM3 type of cements are in fact more durable and sulfate resisting cements than sulfate resisting Portland cement. Okay, and if you look at the concrete structural design, the concrete structural design basically always there is an allowable crack width and all the things. Okay, so the allowable crack widths for the reinforced concrete members and pre-stressed concrete members without bonded tendons, okay, it is 0.3, both for reinforced as well as the pre-stressed members without bonded tendons. Whereas it is pre-stressed members with bonded tendons, the allowable crack width for durability is 0.2 mm. Okay, so these are all the different exposure class. So when it comes to the structural concrete like XC2 to XC4 of exposure classes or XD1 to XS3 exposure classes, the crack widths you need to follow like 0.3. That is actually for the reinforced concrete and pre-stressed concrete members without bonded tendons. Whereas if it is with bonded tendons in pre-stressed members, it is 0.2 mm. Okay, so just now I mentioned when you use high durable cements, actually you can go for a lower concrete strength class. At the same time, you can go with lower concrete yeah, here basically here the exposure classes, this one is for the 50 years of service life and 100 years of service life if you look at the right side description. So in this exposure class, this exposure class is related to corrosion induced by carbonation related scenarios. Okay, so when corrosion related carbonation related scenario, they have defined the strength classes from 25 to M25 to M60 in the standard. Okay, but they have not defined what is the maximum water cement ratio required, minimum cement contents are required. Okay, so because now as I mentioned, moving to the performance based specifications, they are not very much worried about the maximum cement water cement ratio limits and minimum cement content limits. As long as you achieve the concrete performance, it can actually fulfill the required durability. Okay, and again if you look at the nominal concrete cover, also for 50 years of service life, you need to have like 65 mm, whereas 100 years of service life now increased to up to 75 mm. Okay. And if you look at the next scenario, the recommendations, this is the more comprehensive one. You can see here a few details. Okay, so this one is actually corrosion induced by chlorides other than seawater. So those are classified under XD exposure classes. In the XD exposure classes, basically if it is XD1 and XD2, those are actually less severe, less aggressive exposure classes compared to XD3. Okay, so when you look at the 50 years of service life and 100 years of service life, these graphs consist of three kind of information. One is the upper portion is basically representing the minimum cement content scenario, whereas the lower portion is representing the maximum water cement ratio limits they defined here. But in the new standard, they have not defined what kind of strength classes are required. Okay, and at the same time they have mentioned like you have to use high durable cements for XD3 class compared to the XD1 and XD2. So for XD1 and XD2, you can use any type of cement, but for XD3 classes, you have to use high durable cements. The high durable cements also here I have given on the right side, A1 to G1 less durable cements, even though these are durable than ordinary Portland cement and sulfate resisting cements. Likewise, in the second row on the right corner, basically A2 to D3, those are intermediate kind of durability and but better durable than A1 to G1. Whereas if you use A4 to F4, those are very good and those are the high durable cements. So if those places, those scenarios like corrosion induced by chlorides other than seawater. No, I think this one is actually there is a typo error. This one is actually from the seawater. So the excess exposure classes refer to the corrosion induced by chlorides from the seawater. Okay, so here there is a typo error. Okay, so as I mentioned, basically for 100 years of service life and 50 years of service life, the minimum concrete cover only now varied. There is a 10 mm difference, whereas the maximum concrete cover, the minimum concrete cover, the upper limit is actually still it is same both for 50 years of service life and 100 years of service life. So when it comes to the durability, concrete cover plays an important role. Okay, so that is the reason why the concrete cover, basically the alkalinity scenario, the pH maintaining surrounding the rebar and all the things are achieved only when you have a proper amount of concrete cover. At the same time, even the concrete is carbonated also. If you have enough concrete cover, the carbonation doesn't reach to the rebar level, whereby it doesn't affect any of the corrosion related scenario. It can be the initiation of the corrosion or a propagation of the corrosion. All those things can be minimized with the proper amount of concrete cover. Okay, so just now I mentioned about the cement types. Here you can see the table, the 27 products in the family of common cements. Okay, so here they allow clinker is nothing but ordinary Portland cement portion, whereas you can go with high amount of GGBS up to 95 percentage, and you can go with silica fume 6 to 10% or even higher, especially when you are dealing with high strength concrete. Okay, and natural pozzolans, it can be natural type or calcine type. Fly ash, burnt shale, limestone powder. Okay, all those are allowed in the cements now. Combinations up to 35 percentage, or otherwise if you are looking at the composite cements, you can even go with different combinations, but you need to comply to certain cement quality requirements. It may be in terms of a 2-day strength or 28-day strength, to categorize the cement quality into like 42.5 or 52.5 kind of cement categories and classifications. Okay, so on top of that, as I mentioned, you can see on the right side, table 2, SAM3, SAM3B type of cements are sulfate resisting Portland cements. Those are actually, I mean, sulfate resisting. Those cements can have can fulfill the sulfate resisting behavior. At the same time, those will give you less expansions and things like that, and much durable than sulfate resisting cements. Later on, I will show you one slide got examples comparison of the OPC and sulfate resisting cement against the SAM3 type of cements. Okay, SAM2 and SAM3 type of cements. Okay, so those basically will enhance the durability. Okay, so now there is a new standard. I mean, the standard now, earlier we have only SAM2A, SAM2B type, but now they introduce new cements in the standard in the SSEN 544 part 1, which is actually adopted from the BS 8500 part 1. It consists of new categories of cements. Okay, composite based cements. These composite based cements basically nowadays you might come across like LC3 cements. So what is this LC3 means? Lime calcium clay cement. Okay, so here you can see three C's and one L, that is called LC3. So what composition basically the LC3 cement consists of? Typically 30% of calcium clay, 50% of the OPC, 15% of limestone, whereas 5% of the other minor constituents like gypsum and things like that. Okay, so this is the typical combination. So nowadays they are allowing limestone powders to produce the cement. Okay, so now many of the places, especially in Europe, they are extensively using, because when it comes to Europe, the availability of the GGBS and all are very little, because most of the steel production and GGBS production takes place in China and India and other parts of the Asia, whereas Europe and US, the cement production, especially the slag productions and things like that, are not that huge. They are relying on other kind of materials, even though they have some supplies and things like that, some production locally and things like that, but the amounts are not sufficient, so they are relying on other kind of cementitious materials. Okay, so when it comes to the durability, you have to use high durable cements. This one is actually, when it comes to marine applications, again there is one more standard called BS 63449-1. They have given some recommendations with different kind of exposure classes. They defined as XS M2, XS M3, XS M4, like that, which are actually similar to like XS1, XS2, XS3. Okay, so you have to go with the high durable cements when it comes to the XS3 or XS4 type of exposure classes. Okay, so how to achieve the durability at the same time sustainability? Really, it can be sustainable when you use supplementary cementitious materials. Those basically will gives you durability. Okay, so those durable structures basically last longer, which require less maintenance. So require less maintenance means basically you can lessen the cost to repair and reconstruction, and also it will lessen the environmental and social impacts. Basically the air quality and CO2 emissions and all the things can be reduced subsequently, because if you are going with less maintenance and things like that, means your operational emissions and things like that also will be lowered out. So the upfront embedded impacts can also be effectively spread over longer period, because you are enhancing the durability and the service life. So the whatever the 11% of embedded carbon emissions from the constructions up to the construction stage can be spread over to longer periods. That basically reducing the annualized embedded environmental impacts. So apart from that, these benefits ultimately reduce the environmental impact by reducing the less construction or reconstruction and lowering the CO2 emissions depending on the raw materials consumption, energy usage, noise and dust emissions and pollutions. Okay, so these are just example. As I mentioned earlier, I will go show you some numerical numbers how effectively with the cementitious materials usage can reduce the carbon emissions. Suppose if you look at this one, uh, if you use ordinary Portland cement, here the kg equivalent CO2 per ton of cement production for the A1, B1, C1 cements, it is 923 uh, kg equivalent of CO2 emissions. Whereas when you use GGBS up to 25 percentage, or even if you use higher proportions of 25 to 50 45 percentage, your reduction of CO2 emissions in the last column you can see, you can reduce when you use up to 25 percentage combination with other composite cements, you can reduce up to 47 percentage, or only if you use only 24% GGBS, you can reduce up to 20% of CO2 emissions based on only the cement replacement scenario. But when you use up to 45 percentage of GGBS, you can reduce up to 40 percentage CO2 emissions. And if you use up to 65 percentage, you can reduce close to like 50 percentage, 49.4 percentage. Okay, but if you use like SEM3B type of cements with 66 to 80 percentage range, you can even reduce beyond 50 percentage up to 70 percentage at the cement stage itself. Okay, because as I mentioned earlier, 90% of the CO2 emissions comes from the from the concrete industry, comes from the cement production only. So if you tackle the clinker content usage as little as possible and rely on high cementitious materials, those will substantially reduce the CO2 emissions. So as I mentioned earlier, I show you some example how durable it is when you go with 70% GGBS. You can see the right side, the resistance to sulfate attack indicative trend of the performance when it comes to the durability. GGBS 70% which comes under A4 category of cement based on the new standard will give you less expansion, very minimal expansion compared to the ordinary Portland cement, that is the A1 cement. You can see at the initial stage of the graph, it gives you huge expansion. Okay, even again if you look at the sulfate resisting Portland cement as a G1 category of cement, it may delay your expansion at the early age, but after 20 months or 25 months, the expansion is as equivalent as like ordinary Portland cement. Okay, so whereas when you use GGBS up to the 70% GGBS kind, your expansions are substantially lower. So that is the reason why now sulfate resisting cement is completely replaced by the SEM3A kind of cements. If you look at the left side graphs, okay, the first one is actually the chloride diffusion. The chloride diffusion for the sulfate resisting Portland cement is very huge compared to OPC. If you compare with GGBS and fly ash based cements, it is much higher. Okay, so that is the reason why the CO2, I mean the supplementary cementitious materials will give you durable concrete. And also in the earlier slide I showed you, basically it can reduce the CO2 emissions also substantially. Okay, so even the same thing applies to the alkali silica reaction scenario. Okay, the protection against alkali silica reaction also, GGBS concretes are those concretes with the fly ash performs much well above the ordinary Portland cements. Okay, so these are all some examples which were done the research and published with high replacements of GGBS in 100% crushed granite fine concrete. Okay, so if you all are interested, maybe can find more details from the publication. Okay, so nowadays, as I mentioned, the crack width is actually one of the important parameter in order to perform the durability of the concrete. Okay, so use of fibers helps to reduce the uh, crack widths. Once you control the crack width, basically you can enhance the durability of the concrete. So the macro fibers, both steel macro fibers as well as the polypropylene macro fibers nowadays getting popular. Okay, so those basically enhance the uh, tensile capacity. Okay, so whereby you can maybe minimize your rebar usage in the constructions. At the same time, it will reduce, those will reduce the crack width and enhance the load carrying capacities and things like that. So if you look at the definition wise, what is the definition between the macro and micro fibers are basically 0.3 mm is the thickness. If anything more than 0.3 mm, call it as a macro, whereas less than 0.3 mm is call it as a micro. And in high strength concretes, especially to address the fire resistance and spalling resistance, use of microfibers are very popular. Polypropylene fibers. Okay, sometimes they use steel fibers also, but micro polypropylene fibers are popular in high strength concrete to reduce the spalling. Okay, especially when experienced a fire accident and things like that. Okay, so if you look at the crack control and durability with fiber reinforced concrete based on the ACI PRC 544-10 .10-21 technical note, they have mentioned clearly, basically the fibers helps to reduce the crack width under severe loads, and also they also change the crack morphology and the pattern. Suppose if you look at the below picture, if it is a reinforced concrete, we always design minimum reinforcement in the reinforced concrete structures basically to tackle the cracking, to address the cracking. Okay, but if the concrete is cracked, if it is a reinforced concrete, the crack width may be very wide. But when you go with fiber reinforced concrete, the crack widths are reduced substantially when you use fiber reinforced concrete. So once the crack width is reduced, means your durability of the element will be enhanced much better because of the reduced crack width. Okay, so let's look at some details about durability and service life of concrete constructions before we close for the day. Okay, so when it comes to the concrete durability, we always look at the Pantheon. Okay, the Pantheon in Rome come to our mind because this is a very old non-reinforced concrete structure. It was built like 2000 years ago, and it has a very good architecture, the internal architecture and all the things. They have a natural ventilation hole at the top. Okay, so when it comes to the concrete durability, they inside this dome basically they have drains and all, because rainwater also will enter into it, so you need to have a drains to evacuate the water in case of rain. So if any ponding water or improper drainage and all the things, those will affect the durability of the concrete, especially uh, in the service life stays. Okay, so if you look at the mechanism between the concepts of durability and performance, you have to have a very quality construction, and you have to have very quality construction materials usage and workmanship and proper curing and all the things. On top of that, you need to have proper usage of the right materials and right construction methods, right thickness and all the things. So those comes under the design scenario. You have to have a proper detailing, rebar spacing and all the things in order for the concrete to flow and fill the forms completely, whereby you can have a very good cross section uh, element after construction. Otherwise, if any honeycomb or crack or anything basically will affect. So you need to have a proper control. So how you will get proper control? you have to have a proper construction. So these are all typical factors that can affect the durability of the concrete structures. So you have to have a proper materials. At the same time, you have to use right design concepts and workmanship. Any of the things which you compromise basically will because when you design the structure always based on certain exposure conditions, if any inferior quality or inferior construction methods are adopted, the attacking of the parameters, the durability of the concrete will be attacked by the influencing parameters will be at much early stage happens once you use improper materials and construction techniques. So when it comes to the concrete deterioration over a period of time, it cannot be eliminated. So we need to do proper maintenance. If you don't have maintenance, the durability of the structure will be affected. Okay, so I don't go into the details. All these are the durability affecting parameters. So carbonation, chloride, corrosion of steel in concrete, the acid attack, sulfate attack, all those will influence. So that is the reason why we have to have a design for durability in terms of having a good quality control of concrete, as well as good thickness of the concrete cover and all the things. Okay, so and when it comes to the concrete constructions, non-structural cracks tends to happen, but non-structural cracks you may have to do proper rectifications and things like that. The repair industry is again another industry, especially when it comes to the repair and rehabilitation of the concrete structures as and when it is required. So you need to have a periodical maintenance and periodical inspections and things like that with a proper repair and rehabilitations, because the concrete performance will be affected because of errors in design, defective materials, poor constructions and things like that. At the same time, something like a human age factor, the structures will experience some deteriorations. Those are it can be due to corrosion, erosion, or sulfate attack or chemical related things, or otherwise sometime maybe happen due to intermittently, naturally, accidentally, like cyclones, typhoons, those kind of things. And that is the reason why you have to respond on time, and you have to react with the proper inspection and maintenance. If any delay in maintenance, there may be a chance of collapse and things like that. So that is the reason why when it comes to the design service life, suppose you are designing a concrete for 50 years of service life or 100 years of service life, if you don't do any inspection and maintenance, it may end up, suppose if you design for 50 years, it may collapse after 10-15 years. Okay, it depends on how quality construction and how quality workmanship was involved. Okay, but if you do a periodical inspection and maintenance and repair and rehabilitation and things like that, then you can extend the service life up to the design service life. Okay, so it is nothing like once you constructed means it will be last for 50 years or 100 years. You have to do your periodic inspection and maintenance. You will achieve the complete design service life when routinely maintained. Okay, so again, as I mentioned, basically the defects can be concrete related defects or reinforcement related defects. Concrete related defects because of the mechanical, chemical, physical or fire related damages, whereas reinforcement related defects because of the corrosion of steel in concrete and things like that, that can affect the performance of the structure over a period of time. So in order to have a durable concrete structure, basically you have to consider what are the affecting parameters. You have to react and respond, and you have to do the necessary protections and repairs. So it can be a surface protection sometime, it can be a reinforcement protection sometime, it can be a structural and a non-structural repair sometime. Okay, so again, I don't go into these details. As I mentioned earlier, the both defects are classified into two categories only. One can be concrete related deterioration, another can be reinforcement related deterioration. So when it comes to the products for durability enhancement, as I mentioned, surface protection products, injection products. The injection products also, again, sometime you need to choose the right product. Sometime you may have to choose the flexible type, Sometimes you need to choose the ductile type, sometimes you need to choose the swelling type. If it is a wet crack repair, you need to use the polyurethane kind of swelling kind of products you need to inject into the cracks in order to seal up the wet cracks. Okay, so the wet crack means crack is seeping the water. Okay, so anyway, finding the source of entry of water is a primary thing that you need to eliminate. Okay, so after that the repair and rehabilitations comes in terms of protections and things like that, sexual and non-sexual repairs. Okay, so sometimes we may have to use the anchoring products. And in order to protect the steel reinforcement, if you are involving in any of the health monitoring or rehabilitation of the concrete structures, after remove the concrete cover, you need to do the treatment to the old the existing steel. If the steel is actually not affected so badly, then you may be go with minimum rectifications and repairs. But if it is affected badly, you need to do a thorough removal of the concrete covers, or otherwise you may need to depend on cathodic protection kind of methods instead of removing the concrete. Okay, so you have to see what kind of damage and what is the cause basically creating the problem in terms of compromising the durability. So the identification of the potential causes are more important in order to do your maintenance strategy and planning program, especially to do the rehabilitation program. Suppose if you look at this one, three stages are given in the repair framework. Okay, so the first portion is the deterioration surface. In the deterioration surface, you can see like delamination, spalling, heavily corroded rebar, cracking, contaminated concrete, and all the things. So when it comes to the surface preparation and removal, sometimes you may need to remove the concrete beyond the reinforcement level. Okay, based on the level, how depth the concrete is affected with carbonation or other kind of chemicals and things like that. Okay, so but if you go through the rehabilitation and repair scenario, it depends on a type of structure. Sometimes you may not able to remove the concrete, then you have to depend on corrosion cathodic protection related systems. So the cathodic protection related systems basically suppress the additional corrosion reaction, additional corrosion to the reinforcement without removing the concrete. Okay, so the last portion is basically the repair location. So in the surface preparation, basically you have to do proper preparation. So you have to give a substrate preparation very thoroughly, remove the contaminated concrete, and you need to have a cleaning up of the steel reinforcement, and again apply the reinforcement protection coatings. And you need to have a proper edge condition. You need to create the proper key and interlocking to the new concrete as well as the new old concrete. Okay, so at the repair stage, basically when once you have a thorough preparation and things like that, you are able to achieve a very durable repair construction. So here they have indicated like reinforcement corrosion protection first, followed by bonding, applying the bonding primer and things like that, then followed by apply the repair mortar. The finally you will go with a skim coat or those kind of smooth plasters and things like that before you are going for coating and painting and things like that. So how to achieve the long-term durability? Basically you have to have a 3Q principle: quality materials, quality construction, quality maintenance. Then only you are able to achieve a long-term durability. Okay, so let's come back to the statement of problem for a research proposal, project proposal. So again, in fact, all these points which I mentioned earlier. Okay, so how to come up with a project proposal? You have to see what kind of a project is actually announced by the government. So whether your research capabilities are suitable to the project proposal or not. If it is actually your core area, so then you can actually see what is your strong points, whether you are strong at materials, whether you have any characterization methods, or otherwise you are good at both analytical and finite element modeling and things like that, because those analytical and numerical methods, you require some inputs. Okay, so these inputs where you will get, maybe you need to run some experiments to key into the analytical analysis or numerical analysis to come up with some kind of prediction models and things like that. So if any PhD student is working, they may sometime have to do both experimental and analytical, or both finite element modeling and things like that, in order to have those long term predictions and things like that. Sometime you may have to see what is the project proposal, what is the focus of the proposal. Based on that, you have to do your framework. Okay, sometime you can come up with some innovative materials where it can optimize the current existing materials costs. Okay, suppose if you are in the market, only this kind of material is available. Okay, but this material always have certain costs. So if you come up with some new formulation or new material, if that can actually optimize the cost, then your material can be a alternative material to the existing material. So likewise, you have to see whether your optimization is related to the method or characterization systems and things like that. So in the statement of a problem, you have to have the introduction to the problem based on the type of funding, or sometime the industry team and partners, they may always have some internal problems. The internal problems, also the research problems, they may come and consult you. You may actually give them a solution. So that is actually a consultancy project. Okay, it can be a small consultancy project, or sometime if the organization is very big, they may allocate a huge amount of funding for the R&D. Okay, so you understand the problem. So introduction to the problem, you have to see what is the background of the problem, what kind of you have to explain why the problem is important and provide relevant facts, data and examples. Then only they will buy your idea, then only they may be prepared to give a funding. And you have to describe the issues and challenges, clearly define the specific problem that need to be addressed. Okay, so likewise, I don't go into the details, I just go through the subheadings. The impacts and consequences you have to describe as well. Then only they will understand, okay, the consequences are so severe, we have to spend money to find the solution, like that. So what are the existing solutions, whether any gaps are there to the existing solutions, then you come up with an objective to give a comprehensive solution to the problem. Okay, so research is basically nothing but creation of a new knowledge. Okay, sometimes generate new concepts, methodologies, and understanding I have a better understanding of the problem to come up with a solution. Okay, so the R&D is actually to provide a final solution basically. Okay, so innovative activities undertaken by the corporations or governments or academics. Okay, so the aim is basically developing new services or products, improving the existing ones otherwise. Okay, so the development of a potential new service or solution, or the production process, that is nothing but a R&D. Okay, so I don't go into the conclusions now. It is almost like 8:56. So again, now the whole world is looking towards the sustainability and addressing the CO2 emission related issues, and the targets, global targets of net zero emissions by 2050 and all those. So by using supplementary cementitious materials and those uh, basically enhance the durability of the concrete structures, at the same time they reduce the carbon emissions as well. So we have to have a transition of shifting from OPC cements to cement SCM based cements is one of the way we have to move forward to tackle both embedded carbon emissions as well as the durability of the concrete structures. Okay, so thank you all. That is all my presentation. If you have any questions, we can discuss for a while. Otherwise, thank you all.
Thank you, sir. Any question from a participant? Any question from participant? Okay, thank you very much, sir, for your hello.
Yes, yes, continue. Yes, I can hear you.
Anyone asked to question? Hello. Okay, thank you very much, sir. Nobody
Yep, yep.
has a question, maybe.
Yep. Thank you for thank you everyone. Basically, I hope you all learn something from my presentation that will be useful for your planning and guiding the students, or looking into provide the consultancies to the industry, whoever approaches you. Thank you.
Sir, good evening, sir.
Yes, yes.
Sorry, I have small doubts, sir, actually.
Yep.
Sir, in the slide you shown products for durability enhancement. There, can you explain in injection products, sir, how we do injection to the existing solid structure, and what is that FDS? Can you explain?
The injection products are nothing but if you are having a crack, a structural crack or non-structural crack, you need to inject, because if it is a non-structural crack, sometime it may lead to some permeation of water through the cracks and things like that. Okay.
Yes.
So you have to see whether this crack is a, again, dormant crack or any active crack. If it is a dormant crack, you can actually go with a rigid materials. You can go with like a rigid epoxy kind of materials to inject the crack. Okay. Whereas if it is like a wet crack where there is a water seepage you are experiencing during the rainy time, or maybe some places where the external surface is actually exposed to the soils and water, whereby these cracks are letting the water to permeate into the structure, basically you have to repair through injection products like polyurethane materials, grouting and things like that. So the injection is nothing but not to the solid structures. Wherever you need to do the rectifications of crack repair or those kind of damages scenario, you have to use the injection products.
Yes, sir. So also you have mentioned if you use fiber reinforced concrete, durability will become more when
Yes.
compared to regular concrete. So what if in case if any cracks occur in fiber reinforced concrete, because nowadays we are using fiber reinforced concrete. I mean, not nowadays, just in recent years.
Okay.
So did we have did I don't know, have we find any cracks or any deterioration in the fiber reinforced structures? If any case studies, please tell us, sir. If we find any.
When it comes to the fiber reinforced concrete, I mean, when it comes to the concrete tends to crack. It is an intrinsic behavior in the concrete constructions. Concrete cracking cannot be avoided. Okay. When it comes, when you construct with a fiber reinforced concrete, as I mentioned just now in one slide, if it is just a normal reinforced concrete, the crack, if anything is initiated, the crack width will be wider. When you use a reinforced concrete, basically the crack width will be much lower, even though with the same loading scenario. If you are using a normal conventional reinforced concrete, the crack width may be like 0.4 or 0.5 in case if the crack is happened. Whereas when you use a fiber reinforced concrete, at the same scenario, your crack width may be 0.1 instead of 0.5. So this reduced crack width basically helps to enhance the durability, because this 0.1 is actually just now I mentioned the maximum allowable crack width of 0.3. This 0.1 is actually doesn't let the water to penetrate into the concrete, because if any water penetrate into the concrete with less than crack width of less than 0.2 or so, it will water react with the cementitious products, and the calcium hydroxide and other kind of products basically will fill up the crack. And if you look at the non-structural cracking report by the Technical Society UK, whatever the crack with less than 0.2 usually doesn't require any rectifications and things like that. Whereas when you have a wider crack width, definitely you have to do the rectifications. Okay, otherwise it will initiate the corrosion reactions and corrosion of steel in concrete and things like that. Yeah.
Okay, sir. Okay, sir. Thank you, sir. Your presentation is very good, sir. We enjoyed a lot.
It's my pleasure. Thank you.
Yes.
Yes, sir.
Good evening, sir. I am Ashok speaking.
Okay.
Sir, currently I am using a slag cement in my consultancy. But
Okay.
while during the mixing of the concrete, I am experiencing the difficulty in workability. So, can you suggest how to overcome this issue, sir?
But what kind of application you are looking at?
Sir, general applications I am looking for the that slag cement.
Yeah. But when it comes to the use of a slag cement, if you do a direct replacement, definitely you will end up with
Complete.
workability issue.
Not at all using any cement. Completely replacing the cement, OPC cement. 100% slag cement we are using, and experiencing the difficulty in workability. Concrete is not at all able to possible to mix. But the strength, whatever the strength we got, the strength was very good. But durability issues were the major issues.
Yeah. I mean, the workability, maybe you see, are you using any admixtures to produce the concrete?
Yeah, sir. Initially, we were used the admixture. Then after we found the difficulty in workability, again we removed the that admixture, and then simply we have added the water, and we got the little bit good workable concrete.
You have to see basically I presume you are casting for some non-structural applications or so. If it is structural application, you may have to approach a proper consultant. Okay, so basically if you have a specific requirements in terms of specification or in terms of durability criteria and things like that, you have to holistically see whether whatever the recipe which you are intending to use suitable to your application or not. So you may need to do some modifications to your recipe. Sometime you may need to bring in other kind of products. The admixtures, once you add admixtures, means it doesn't mean that it will affect the workability. Sometimes you may have to consider different kind of admixtures, or otherwise you may need to reduce the dosage, or otherwise you may need to reduce your water content in the mix and things like that. Okay, so end of the day, if you have any specific things, I think Meena madam have my email address. You can actually contact me. I have given my biography to Meena madam, including my email address. Okay, so if anything specifically you are having these kind of criteria need to achieve, maybe I will see whether I can suggest you anything or not. Yeah.
Yes, sir. Thank you so much, sir. And very informative session.
Yep.
Thank you.
Any more question from participant, please? And so, today sir is with us. Maybe other day by mail only we'll contact him. So now he is in front of us. You may ask any more question. Otherwise, we'll end the session.
Thank you, madam. Yeah.
Thank you very much, sir. And sir, if it is possible, you will share your PPT to us.
Okay, maybe I will maybe filter some of the contents and I will give you
Yes, some of the part you can filter it and you
Yep,
will
yep.
share it.
Okay.
Thank you very much, sir, for
Excuse me, sir.
nice presentation and informative session.
Okay.
And
It's my
we'll
pleasure.
contact you, sir, in
Yeah,
future.
yeah.
Thank
So I'm actually involving in some of the conferences as a committee member and things like
Committee
that.
members. Okay,
So
sir.
if you guys are actually interested to participate in any of the conferences in Singapore, I will share to you the contacts. I mean the flyers and things like that. You guys are welcome to visit. Okay, so
Yes, sir.
yes,
Definitely.
I think particularly for the PhD students and all, they need to fulfill certain publication requirements and things like that, right? So they can actually visit and present their findings and things like that. Okay.
Sure, sir. Thank you
Okay.
very much, sir.
Okay.